Good afternoon, everyone. Welcome to the first International Year of Basic Sciences for Sustainability Development 24-hour-long webinar. My name is Monica, and I'm a scientist at Triumph, Canada's Particle Accelerator Center, located in Vancouver. Together with two of my colleagues, Oliver Stelzat-Chilton and Silvina Ponce-Dawson, I'm happy to co-host the part 5 of the webinar, which we are broadcasting from Triumph. I would like to start from the acknowledgement that Triumph is located on the traditional, ancestral, and unceded territory of the Musqueam people, who for millennia have passed on their culture, history, and traditions from one generation to the next one on this side. Triumph's home has always been a seat of learning. This webinar is held in conjunction with World Environment Day, which observed on June 5th to raise awareness and encourage global action for the protection of our environment. It serves as a platform to address pressing environmental issues and promote positive changes in behavior and policies to safeguard the planet for future generations. So now part 5 of the webinar features contributions in the form of talks, panel discussions, and local activities in local languages, ranging from Argentina to Canada, on a variety of exciting topics. I would like to start with a challenge related to the periodic table of elements prepared by the International Union of Pure and Applied Chemistry, IUPAC. Everyone is welcome to participate in it throughout the duration of part 5 of this webinar. So let me share screen with you again.
Hello, everybody. You already know the periodic table of the elements, where all the chemical elements are grouped into columns and rows. But how well do you know these elements? I propose you to take the periodic table challenge, an online quiz that is produced by the International Union of Pure and Applied Chemistry, the IUPAC. Your challenge will be to answer 10 randomly chosen multiple choice questions about the elements. As any effort should bring a reward, you will first get a certificate from IUPAC if at least 60% of your answers are correct. But there will be more for this special edition at the occasion of the 24-hour online event organized by the International Year of Basic Sciences for Sustainable Development. Among the winners of today, we will randomly select 3 who will receive a poster of the periodic table signed by 13 chemistry Nobel laureates. You can play alone or with a team from 5 a.m. UTC 5 June to 5 a.m. UTC 6 June. So, how do we play? First, go to the homepage at iupac.org. You can just enter periodic table challenge in your favorite search engine. You will certainly find it easily. You can choose your favorite language, and then here, your difficulty level. Once done, you have to choose an element, which will be your avatar. Let's go. Now, be careful. you have to enter your name. And here in the school institution box, type IYBSSD so that you are sure to enter the special edition competition. Do not forget your email, your city, your country or region. Then send. Are you ready? Click on play. And here is the first question. And if you do not reach the 60%, you can just play again. But do not forget to follow also the very interesting talks, panels, discussions, interviews, videos we are proposing to you all along these 24 hours. We hope you are enjoying this event.
So we have been informed that there has been a small change in correction to the periodic table challenge. And right now, we would like to ask you actually to use the acronym for International Year for Basic Sciences and Sustainable Development, IYBSSD, which should be added in the field of city. You can leave the city and then put space and that acronym, or you can just use that acronym, but don't use it in the school institution field. All right, so right now we are ready to introduce our first contribution, which is a panel discussion on basic science for sustainable development, the case of Latin America and the Caribbean, moderated by Enrique Ferrero from RFP LAC ISC Chair from Colombia. And the panel will feature 3 speakers: Germán Poveda, who is a member of Colombian Academy of Exact Physics and Natural Sciences; Juan Fernando Salazar, who is a member of Colombian Young Academy; and Graciela Diaz Delgado, who is a member in the Liaison Committee, Regional Focal Point for LAC ISC. So Germán, I believe the floor is yours right now.
Thank you, Monica. First of all, I would like to thank Enrique and the organizers for inviting me to participate in this very relevant panel. So I'll start by sharing my screen, I believe. Let me see. And okay. So I hope you're seeing my screen right now. Okay, so I'm going to talk about the impacts of climate change and land use change in Latin America and the Caribbean. Let's start by saying that the conclusions of the 5th and 6th reports of the Intergovernmental Panel on Climate Change are the following. The warming in the climate system is unequivocal, and since the 50s, most observed changes are unprecedented in the last decades to millennia. Second, that the human influence on the climate system is clear. And third, that limiting climate change will require substantial and sustained reductions of greenhouse gas emissions. Of course, the important thing here is that temperatures worldwide are rising rapidly. Here we can see an animation from the last 200 years or 150 years, from 1880 to 2022. Blue colors are colder than the 3 decades from 51 to 1980, and red colors warmer than those 3 decades. As we can see in the recent years, we have been experiencing warmings, very rapid warming, especially in the northern hemisphere and in the Arctic Ocean. So this is causing a lot of environmental, societal, economical, and all kind of crises with very important consequences worldwide, and especially for the developing countries like in Latin America. Here we can see that causes of the climate change, is of course associated with the emission of greenhouse gases, especially CO2 and methane to the atmosphere, and in second term by deforestation. So 80% of the greenhouse gases emissions are due to the release of greenhouse gases by industry, by transport, by energy system, but also 20% of CO2 emissions to the atmosphere is due to deforestation, which is a problem that touches very, very closely in South America. So we're gonna discuss the two issues here, because there are these two issues are imposing tremendous challenges for Latin America and for the global South, especially. Not only carbon dioxide, but methane, of course, is increasing because of due to the emission of greenhouse gases by agriculture, by cattle ranching, and many other processes. These are some of the observed impacts of climate change and land use change in Latin America, evidenced since the fifth assessment report of the IPCC in 2014. I'm not going to go into the details of this transparency, but it's enough to say that every one of these arrows are indicating if temperature, rainfall, river discharges, land use, and vector diseases are increasing or decreasing associated with climate change. These are not expected outcomes. These are already observed impacts of climate change in the region. So as you can see, all over the place in Latin America, we are feeling strong impacts of all those sectors and systems associated with climate change, with very important economical and societal implications and impacts. One of the main evidences is the intensification of stronger hurricanes in the North Atlantic and the Caribbean Sea in the recent years, a prediction that has become reality due to climate change, because it's very easy to show that in a warmer climate and a warmer ocean, of course, the development or the formation of hurricanes and cyclones in the tropical oceans is increasing, and of course we are feeling the consequences of all those hurricanes in our region, especially in the Caribbean, in Central America, and in other South America. The projected changes, of course, are dependent on the different scenarios, future scenarios of climate change, depending on 1.5, 2 degrees or 4 degrees, and in different variables like maximum temperature, total precipitation, maximum 5-day precipitation, and consecutive dry days. All over the place, the impacts and the consequences are going to be huge and very important for the region in the next decades and until the end of this 21st century. The observed impacts of climate change on ecosystems are also very important in our region, because in Central and South America, in small islands as in the Caribbean, but also in tropical forests, in mountain regions, and in very important biodiversity hotspots. Latin America houses one of the most important biodiversity hotspots on Earth, and the expected impacts and the observed impacts of climate change on those ecosystems in their structure, in the species range shifts, and change in timing and phenology of different ecosystems are affecting very, very strongly all over the place in Latin America and the Caribbean. So this is a very important issue, because the Latin America is perhaps one of the most biodiversity, one of the regions with the most extraordinary biodiversity on Earth. So if climate change is affecting these ecosystems, of course, the biodiversity of our continent is in peril. And of course, this is going to impact not only the sustainable development of the region, but also the economic development of the region because of the importance of bioeconomics for the future of the region. So this is a very, very important issue for our continent. Of course, one question is that if we are experiencing or witnessing more El Niño and La Niña events, because also El Niño and La Niña are parts of climate variability, natural climate variability, but of course, climate change is increasing and is affecting their intensity and frequency, as we can see in these recent publications associated with forecasted and observed more frequent occurrences of El Niño and La Niña, with all the strong impacts that those events have in Latin America. Of course, there is this problem of climate inequality, because we know that the global north, to say so, is responsible for causing this problem worldwide, but the global south is the region of the world who bear the burden of health-related deaths, disease, and food security by 2025. So here we can see the geopolitical implications of climate change and the climate inequality that is causing worldwide and especially affecting the global south. So the solution of the problem mainly has to come from the global north. Of course, in the global south, we also have responsibilities associated with, especially with deforestation, but I will touch upon that issue a little bit later. For instance, here we can see the incidence of malaria in Colombia from 1960 to 2 years ago. We can see that there is an increasing trend, that we cannot disprove that climate change is the culprit, but also we see that every time we have El Niño events, we have outbreaks of malaria in Colombia. So especially these vector-borne diseases are going to be increased with climate change, but also with El Niño more frequent, we're going to have more intense and more frequent malaria outbreaks in Colombia in the near future. Of course, as I said, deforestation is a tremendous problem for our region. Here we can see deforestation in the last 20 years from the Global Forest Watch. The red dots are regions who have been deforested during the last 20 years. As you can see here is a tremendous amount of land who has been converted into pastures and cattle ranching lands, with all kinds of implication in terms of hydrological impacts, climatological impact, and biogeochemical impacts throughout the continent. In Colombia, and this is not happening not only in the Brazilian Amazon, but also in all the countries that share the Amazon River basin with Brazil. These are pictures from the Colombian Amazon, and we are seeing here that the same type of processes are going on in Colombia. The destruction of the Amazon rainforest is also very, very worrisome because of the hydrological, climatological, and ecological implications and the impacts of deforestation on the hydrological cycle of South America. And here I want to show you, this is a very nice video because it is showing, this is the result of a very sophisticated climatic model. And here we are going to see the hourly dynamics of the production of water vapor and the transport of water vapor by the winds in tropical South America. And we're going to see the diurnal beating of the diurnal cycle associated with photosynthesis and evapotranspiration that emits water vapor to the atmosphere during the day and closes the processes during the night. We're going to see here from December 2004 to March 2005. And as we can see here, all the transport of moisture starts at the tropical Atlantic Ocean and then it goes to the continent, sometimes evapotranspirating and raining all over the Amazon basin before this water vapor is transported to the Andes, and then from the Western Andes all the way until the La Plata River basin, reaching southeastern South America in places like Buenos Aires and Montevideo. So the whole transport of water vapor in Latin America is controlled by the Amazon rainforest. So if we deforest the Amazon rainforest, we are putting in peril all water resources in South America, because cities like Bogota, Quito, and La Paz gets their water for all type of consumes and usages from the evapotranspiration of water in the low-lying Amazon River basin. So we need to preserve the Amazon rainforest, because this the ecosystem is subject to strong rates of deforestation, putting in peril all the water supply for entire or very large portions of South America. And of course, the Amazon as one of the tipping points of the climatic systems is also subject or is under peril to suffer a so-called tipping point, because scientific research has shown that we don't have to cut the entire Amazon forest to produce a collapse of the forest. Just a 25% deforestation of the Amazon River forest could collapse the tropical rainforest, leading to a warmer and drier ecosystem, something like a savanna. So the entire water cycle of South America depends on the Amazon River basin, but also many other regions of the world associated with the climatic teleconnections are connected to the Amazon River basin. So we need to protect, we need to cut deforestation, we need to stop deforestation of these tropical rainforests for the sustainable development, not only of Latin America, but also of the world. And last word is something that it has been discovered very recently by two Russian scientists, Makarieva and Gorskov. They discovered this wonderful mechanism called the biotic pump of atmospheric moisture, whereby the evapotranspiration of forests causes the condensation of water in the atmosphere, and condensation leads to a atmospheric pressure gradient between the ocean and the continents. So by the evapotranspiration of forests and the condensation of water vapor into clouds, the forests are sucking in moisture or winds from the ocean to the continents, maintaining the continents with extraordinary amounts of rainfall, like in South America. So if we cut the forest, we're going to collapse this wonderful mechanism. And this is another reason why we need to preserve the tropical rainforests of South America. So I'll stop here. Thank you very much.
Thank you, Herman, for this wonderful presentation. And I would like to invite Juan Fernando Salazar.
Hi, can you hear me?
Yes, we can hear you just fine.
Okay, I will share my presentation. Please let me know if you can see it. Can you see my presentation?
Yes, we can see your presentation.
Okay, so hello everybody. I'm very happy. I'm very honored to be here, especially talking after Herman, who's my mentor. So you will note that during my presentation, because I will say some things he already mentioned, and my focus will be to talk about the what I will call the South American water cycle's heart. So we have heard many times that the Amazon forest is like the lung of the planet, or like the lungs of the planet. And that's a fine analogy because of the role of the forest in the global carbon cycle. But that's just a part of the story, because As you saw in Herman's presentation, the Amazon forest is also something that we can describe as a beating heart for the water cycle in South America. And this is because of because this forest plays a major role in distributing water throughout the continent. And this role, or this distribution of water throughout the continent, is threatened by deforestation. So these are the two ideas I will emphasize during the rest of my presentation. What I'm gonna do is to show some examples about what I'm saying. First, we know that we have the South American low-level jet, which you can see in this very nice drawing with the green arrow. Maybe you already know this, but maybe some of you don't. So in a nutshell, this South American low-level jet is like a big atmospheric river. It's like a really big flow of water, transporting water from the ocean through the continent. And it is very important for feeding precipitation in different parts of the continent, especially in the La Plata River Basin, but not only there, because there's seasonal variability. So in some months of the year, this same pattern transports very important amounts of water to northwestern South America, including my home country, Colombia. And this role of the Amazon in distributing water throughout the continent results from many phenomena, I would say complex phenomena, including moisture recycling, which is very important in this story. We talk about moisture recycling when precipitation over a region is fed by evapotranspiration originating in the same region. And this is very important in the Amazon forest. So, for instance, the Amazon River Basin produces around 30% of the precipitation falling over the same basin. And this is mainly because the capacity of the Amazon forest to produce very intense flows of evapotranspiration, which is the transport of water from the surface to the atmosphere. So we have moisture going from the surface to the atmosphere through evapotranspiration and feeding precipitation elsewhere. And this, combined with the winds flowing from the Atlantic Ocean to the Andes, produces something that we could describe as a conveyor belt of moisture that you can see here in the top of the figure. So this is like a conveyor belt that transports water because we have this recycling process. But if we somehow disrupt this recycling process, we could disrupt the conveyor belt and we could affect the distribution of the water throughout the continent. And the best way to disrupt this recycling is by deforesting the forest. So that's a way deforestation is threatening the role of the forest in distributing water in our continent. And we know that deforestation is advancing very, very rapidly in South America. This is also from the Global Forest Watch. And you can see the accumulated tree cover loss during the last 2 decades. So what I'm saying is that this deforestation could cause a heart attack in the continent water cycle. And one important thing here is that we are sure that deforestation will change or is already changing the continent's water cycle, including precipitation. And I say that we are sure because despite the differences among studies, and here you can see like just a random sample of studies studying these deforestation effects on the water cycle and mainly on precipitation. So despite the differences among studies, all of them have in common that the idea that massive deforestation of the Amazon forest will significantly change precipitation in the continent. So there's no room for doubt about it, I think. And how does it look like a heart attack, or how big could be the changes? This is an example from a study estimating how much precipitation falling in different parts of the continent comes from the Amazon forest. So what you see here is the fraction of precipitation originating in the Amazon forest. For instance, in my home country, in Colombia, we have a basin, the Magdalena River Basin, that is very important for our water and energy and food security. And these estimates indicate that, that around 20 or 30% of precipitation falling over the Magdalena River Basin comes from the Amazon forest or from the Amazon Basin, and is threatened by deforestation. This is from a paper we published in 2019. We studied here how precipitation changes with distance to the ocean along wind streamlines flowing over the forest or beyond it. You can see two streamlines here, but we did it with many streamlines. What we found is that precipitation grows exponentially over the forest, exponentially with distance to the ocean, but only over the forest. And this can occur over very long distances, like in the bottom of the slide. This is around 3,000 kilometers, and you can see like a exponential growth of precipitation over such a long distance, meaning that precipitation grows from a relatively small value here to a very high value here. And very importantly, this pattern, or we did not find this pattern over other land covers. And most importantly, we find that this pattern can reverse, meaning that we can pass from an exponential growth of precipitation to an exponential decline of precipitation after the forest. So we are afraid that deforestation could produce changes like transforming an exponential growth of precipitation into an exponential decline of precipitation, meaning huge impacts on water availability in different parts of the continent. And if we have effects of deforestation on precipitation, we will have effects on the whole water cycle, including river discharge, which is very, very important for different things in our societies and ecosystems. This is from a meta-analysis we published last year. It is about studies investigating the deforestation effects on river discharge in large basins of South America. And what we found is that if the studies consider deforestation effects on precipitation, then the consequence of deforestation in these big river basins will be a very important reduction in river discharge in most cases that you can see here. And another important message here is that this deforestation causing river discharge reduction is not only occurring within the same basins, but also outside the basins, mainly in the Amazon. So what I'm saying here is that deforestation in the Amazon can cause very important reductions of river discharge in other basins, like the La Plata Basin in the southern part of the continent, or the Magdalena and Orinoco Basin in the northern part. And another message that I want to highlight here is that we miss this if we use the most typical approach of using hydrological models to simulate deforestation scenarios within a basin, and without considering the deforestation effects on precipitation, if we neglect these effects, we would obtain the result that you can see here in the red and blue box plot, which represent river discharge increases. But we think that this is a misleading result, and this is in part because of neglecting deforestation impacts on precipitation that we know are real effects. So there will be consequences also on river discharge that can be really important for the continent. And there are many more examples, but for the sake of brevity, I want just to conclude by saying that protecting the Amazon forest is in the best interest of our societies. If we lose this forest, our water cycle in South America will suffer something that I would describe as a heart attack, meaning that we won't keep the rainfall and river discharge regimes that we are used to have, and more importantly, that we have planned for. Our plans will not work if we lose this forest. Thank you.
Hello, may I get in? I'm sorry to be late, but I wasn't late. For some reason, I got the wrong link, and I was waiting for, I actually did an introduction, but nothing happened. And then Oliver sent me the correct email. So if you don't mind, I'm going to go back and introduce the two speakers we have had so far. And then I'll introduce Graciela, who is the third and last of the group. So can you hear me? Can people hear me?
Yes, we can hear just fine.
Yes. Yes.
Okay.
Yes,
Thank
Enrique,
you.
thank you.
Thank you. Well, so starting with Dr. Poveda, he is a professor in the Department of Geosciences and Environment of the National University of Colombia in Medellin. He is a civil engineer from the National University of Colombia, has a master's degree in water resources development from the National University of Colombia in Medellin. He has a master's in engineering sciences from the University of California, Davis. He has a PhD in water resources from the National University of Colombia. He has had postdoctoral experience in hydroecology at the University of Colorado in Boulder, has been visiting professor at the National Center for Atmospheric Research in Boulder, Colorado, the Center for Hydrology and Ecology in Wellingford, United Kingdom, and the Max Planck Institute of Biogeochemistry in Jena, in Germany. He is a winner of the Nobel Peace Prize in 2007 as a member of the Intergovernmental Panel on Climate Change. He is a full member of the Colombian Academy of Exact Physical and Natural Sciences and of the World Academy of Sciences. In 2019, he was a part of the international mission of experts convened by the Colombian government. He is currently a member of the Scientific Panel for the Amazon. He is also a member of the International Scientific Steering Committee of the Global Water and Energy Cycles Research Program, and a member of the scientific team of the NASA Global Participation Measurement Mission. He is author and co-author of 15 books, more than 300 articles published in national and international journals, and more than 300 presentations at national and international meetings on hydrology, meteorology, oceanography, hydroclimatology, water resources, advanced mathematics, climate change and climate variability, and their social, environmental, and economic impacts, including agriculture, water supply, power generation, natural disasters, and transmission of tropical diseases. Dr. Juan Fernando Salazar Villegas was very, very shy in sending a very short CV. I know he's done many more things. This is just a summary. Dr. Salazar is a professor at the University of Antioquia. He has a doctorate in water resources. He's a researcher on hydrology and climate issues with implications for sustainability, author of scientific and general dissemination publications on water security, including water availability and flood risk, climate change, consequences of deforestation, climate tipping points, moisture recycling, and watershed management, among others. He is a member of the Colombian Young Academy, which is associated with the Colombian Academy of Exact Physical and Natural Sciences. And the next speaker is Dr. Graciela Diaz de Delgado. She is from Venezuela, from Maracaibo. She studied chemistry at the Universidad de los Andes in Mérida, Venezuela, and obtained her PhD in chemistry at Brandeis University in Massachusetts. In 1989, she joined the crystallography laboratory at the University of Los Andes as assistant professor and has been a full professor since 2002. Among other roles, she has been chair of the crystallography laboratory, chair of the interdisciplinary graduate program in applied chemistry, and director of graduate studies at the Faculty of Sciences. She has supervised numerous bachelor's, master's, and doctorate degree theses. She has more than 70 publications in peer-reviewed and indexed journals and more than 300 presentations in national and international congresses and as invited speaker at prestigious universities around the world. She is a member of the American Crystallographic Association, the International Center for Diffraction Data, the American Chemical Society, is a founding member of the Venezuelan Society of Crystallography and of the Latin American Crystallographic Association. In these organizations, she has participated in many science outreach activities. She was a member of the committee for the celebration at the University of Los Andes of the International Year of Chemistry in 2011 and of the American Crystallographic Association Committee for the celebration of the International Year of Crystallography in 2014. Currently, she serves on the Executive Committee of the International Union of Crystallography, the Board of Directors of ICDD, and is one of the 4 section editors of Acta Crystallográfica E. Since June 2022, she is a member of the liaison committee of the IEC Regional Focal Point for Latin America and the Caribbean. Her research interests include the structural characterization by single crystal and powder diffraction techniques of active pharmaceutical ingredients, precursors and intermediates in the synthesis of pharmaceuticals, commercial pharmaceutical products, as well as natural products isolated from medicinal plants in the Venezuelan Andes. Of particular interest is the study of polymorphism in these compounds, solid-state reactions induced by radiation, heat pressure, and other agents during synthesis, processing, storage, and/or transport of pharmaceuticals. She is also interested in analytical techniques applied to cultural heritage items, symmetry in art, and science outreach. So, Graciela, it's your turn. You have the floor.
Well, thank you very much, Enrique, for the invitation. And thank you. And I really appreciate this opportunity to be a part of this panel of distinguished scientists and to try to present a little bit of the perspective that we have from the crystallography area and how we can approach and try to contribute to reaching the goals that have been set for 2030 with regard to food, water, access, and in general sustainable development. I'm going to start sharing my screen. Let me try again because I'm not seeing the screen, I think.
We can see it.
Oh, you can see it? Okay, I'm the one who doesn't see the screen.
It's very clear.
Okay. Okay. Oops. I'm sorry, we tried this before. Okay. Well, I'm going to try to present some of the work that we can that we have been doing over the years, and that we can do by using, in particular, crystallographic techniques, diffraction, X-ray diffraction on powder samples and on single crystals. And but this applied to assuring the quality and the safety of food and pharmaceutical ingredients as additional techniques, which provide a very complete a view of these very important materials in our everyday life. So, as Enrique said, as I am a member of the crystallography laboratory at Facultad de Ciencias in Universidad de los Andes in Mérida, Venezuela, and my perspective will be a little bit more inclined towards that area of research. See, within the 17 sustainable development goals that have been set for 2030, certainly building and increasing capacities in the characterization of materials is of utmost importance to secure the access to medicines and food and clean water and other many other basic needs that our population has, in particular in Latin America and the Caribbean region. It is well.
Graciela, the slides are not changing. They're not changing. We're the first. We have the first one only.
Oh, okay, okay.
The title.
Yes, I don't know why the screen got so so small. I'm going to start it again because I'm sorry. We checked this and I don't know what happens. Let me see.
Go out and in again.
Okay. Okay, I think we will be able to see it better now. I hope.
Okay, there it is, but probably if you put it in full screen.
Yes. I don't know what happened. We just check it out.
That's just strange.
Yes, let me get out of here. Yes, I think. Okay. Okay, I think
Can you put
it's
it in
just that,
full screen?
yes.
You
Yes.
click down there, right there.
Okay. Okay. Do you see it now in presenting mode only? Okay.
Go ahead, go ahead. That's fine. Okay.
Okay. Yes.
it's-
I'm sorry. I'm sorry.
No, that's
Something happened when I was trying that.
there.
Okay, so in Latin America, there are certainly many efforts that are made to allow the population to secure access to. Let me see. I think this is not. Okay. I think yeah, it's better now. Okay, I think it's better now. So as I was saying, there are many efforts to secure low-cost drugs and other type of products for the treatment of different diseases, and this is using generic drugs. This is facilitated by the patent expiration of many active pharmaceutical ingredients that make it much easier to market the generic versions of the pharmaceuticals. However, there might be a lot of a proliferation of different companies that provide generic materials at a low cost, but it is important to characterize these materials because we need to assess that they are chemically pure, that they are chemically what they tell us they are, and also from the structural point of view, because the stability, the processing conditions, the transport, the storage, and also the bioavailability of these materials depend on the structure, on the crystal structure of these compounds. That's why we are interested in studying the phenomenon of polymorphism. It is also necessary to know the quality of different food ingredients like stabilizers, dyes, different type of mineral supplements, etc., and make sure that they do not contain additives that we know that have been banned in other areas of the world because of dangerous side effects. So we have a very good and large battery of chemical and structural characterization of different techniques for chemical and structural characterization of materials, which include spectroscopic techniques such as ultraviolet, visible light spectroscopy, infrared, nuclear magnetic resonance, absorption techniques, which are very common in laboratories, in academia, in the Latin American and the Caribbean region. There are other techniques also very, very popular and well-known and very much used everywhere, which are depend on the thermal, on changes in the material, on the thermal conditions, different techniques such as chromatography and different other methods. However, the diffraction techniques use where we use powders or a small crystal fragment for the analysis are the techniques that give us the most important information, because they tell us what type of atoms we have in what position within the crystalline structure. And this is very important to understand how the material behaves under processing, for example, how the compound interacts with a particular protein to have some kind of therapeutic effect, etc. And it's good to point out that the FDA considers X-ray powder diffraction as the technique that has to be used for the characterization of pharmaceutical solids. So these techniques are very important for the characterization of materials. So I have tried to frame some the few examples that I'm going to talk about within some of the goals that that can be approached using this type of techniques, or how we can try to solve the problems that arise in the production, for example, of pharmaceuticals, or even in the already the finished product. So I'm going to just show very briefly the characterization of a product that has been sold extensively throughout Latin America. It is still found, even though there are several alerts by different governments that this is not a natural product, it's not a homeopathic product, etc. So we studied a product that is called Reumatrit, that comes in as a duo, simplex and plus, and you have to take one tablet of each one for the treatment or for the relief of pain due to arthritis, gout, or other conditions of the bones or the muscles. Consumers have reported very, very immediate relief, but they experience very serious undesirable side effects. It is interesting that the composition of these products is very, difficult to pinpoint, actually, because some packages may indicate a particular composition formed by plant or animal extracts, and other ones can say that it has something completely different. So, but the worst part is that these products do not have any kind of permissions for manufacturing. Them, they usually have registry numbers that do not exist within the system of, in particular, Venezuela and Colombia, which is the products that we have examined, and they have different types of irregularities. So this is why we think that surveillance and follow-up on this kind of products is important within one of the goals established as a responsible consumption and production of, in particular, in this case, pharmaceutical or any kind of product that is going to be used to relieve the symptoms of a particular illness. So we studied both presentations, both compounds, both products, and we found that they have, actually they are not natural, they have sodium diclofenac and they have prednisolone, which is a common anti-inflammatory and an steroid. They are not natural, they are not bad, but they have to be taken under surveillance by the physician. So in both compounds, they declare that they are natural or homeopathic, but they are really not. So this is one of the things that we can tackle with X-ray diffraction. Another thing that also goes and is related to climate change and the possibility of losing some of our biodiversity is, for example, the study of secondary metabolites from plants that exist in the Andes, the Venezuelan, Colombian, and in all the Andes region, that have been used for a long time for different types of conditions. We have studied in our laboratory, for example, antivenoms materials, some other materials that could be used as antibacterials, fungicides, antivirals, anti-tumor compounds. In particular, these compounds come from plants that grow above 3,000 meters and that are very particular and very delicate, and everything that anything, I mean, even small perturbation in the climate, in the rainfall and in weather conditions could jeopardize the existence of these plants. I'm sorry. So this type of work, in this case, for example, we also prepare a new form of a bronchodilator called clenbuterol, which could be explored at some point as a possible different type of pharmaceutical, which could be easier to process, or could have, in theory, could have some advantages over the forms that we already know. And this goes, or this will also help in the case of undergraduate or graduate students, for example, because this work has been done as part of the undergraduate and the PhD degree thesis of these two colleagues now of us. So it the work that can be done in this area also is beneficial for the advancement in education and in increasing and building capacity in the analysis of different materials. We have studied different type of compounds, and also, for example, the different polymorphs of flunixin have been studied by also PhD and undergraduate degree students, and that has been published in very respected journals in the area. This is, for example, trichloromethiazide, which is a diuretic that is commonly used in all over Latin America and the Caribbean. And we also collaborate with different groups that are trying to prepare new materials based on known materials that could have a particular effect. For example, in this case, we have compounds similar to rasagiline, which is a compound commonly used for the treatment of Parkinson's disease. So all these projects, all this work can be beneficial not only to the population, because we can help assess the quality of the pharmaceutical ingredients that that we are using, but also help achieving higher education and expertise in particular techniques of characterization of materials. I would say that crystallography is very, very useful in approaching younger generations, and since the International Year of Crystallography in 2014, crystal growing competitions have been initiated in different parts of the world, and for example, Argentina. We will hear from Dr. Diego Lamas later on at 8 p.m. Argentinian time about his experience with these very, very interesting activities that is very is particularly appropriate for encouraging younger generations and of students that could go into work or study basic sciences. Okay. Also, crystallography is very active in courses around Latin America and the Caribbean, and these are just a few pictures of some very large events that we have had over the years. It's very important to note that our area of work and our organizations in crystallography are particularly interested in assuring gender equality and diversity in all the activities. It's within the framework, and it's one of the requirements to receive support from the UCR to carry out different types of activities. So, and just to end, also a very nice opportunity for a partnership with different organizations resulted in the very successful LAMP program, which is Light Sources for the Americas, Asia, and the Middle East and Pacific, that provides support for a team of a student and a professor to spend time at a synchrotron source to learn how to use the facilities and solve particular problems that that the team might have as part of the thesis work of the student. So at the end, I think crystallography is very prone to partnership with governments, for example, industries, academia, equipment manufacturers, and software providers to set up regional or national facilities that can provide services to assess the quality of food ingredients or pharmaceutical ingredients, so that the population can be sure that it's receiving a product of good quality and at a cost that can be afforded by these populations. In this regard, we would like to, yes?
You're ready to finish?
Yes, in this regard, we would like to mention the possibility of the Caribbean Hub for X-ray diffraction, the synchrotron, a new synchrotron source possibly in Mexico, and the neutron source in Argentina. So thank you very much. I'm sorry for the trouble with the presentation, and thank you for your attention.
Thank you, and thank you all the panelists for their contributions. I'm sorry again that I came in late, but I don't know if Germán wants to add anything to what you said, or if we can try to answer a few questions, or Juan Fernando, if you want to add something to what you said.
Yes, Enrique, thank you. I would like to add some ideas that I collected during the weekend associated with scientific knowledge associated with the Sustainable Development Goals. For that, let me share my screen again. I won't take too long, but I would like to show you this diagram, which is here. Yeah. Of course, there's plenty of opportunities for developing very interesting scientific agenda associated with the Sustainable Development Goals. Here we have the 17 goals, and every one of these goals is a tremendous opportunity to develop not only, of course, basic scientific research, but also important applied scientific research and engineering and technology. For instance, this is a very incomplete and, of course, very preliminary table associated or of the sciences that we need to involve to contribute to solve one of the Sustainable Development Goals. For instance, the goals of no poverty requires knowledge about statistics, mathematics, economy, climatology, hydrology, ecology, and of course, transdisciplinary research. And in this regard, I would like to emphasize that, of course, the scientific research is not only necessary in terms of exact physical and natural sciences, but also social sciences, because many of these problems and issues are very much associated with societal, economical, and behavioral sciences. So we need to get together with the social scientists, and also being in Latin America, I think that it's very important to involve the ancestral and the traditional knowledge of our ancestors in terms of indigenous pre-Columbian peoples, because they have been living here for more than 10,000 years in peace with their environments and with their ecosystems, and they have a tremendous amount of knowledge associated with the functioning and with the behavior of our ecosystem. So I think that we need to get together, to join forces between the natural scientists, the social scientists, and the ancestral traditional wisdom and knowledge. And here I have some other examples for many of these sustainable development goals of all the sciences, basic sciences that we need to bring to the fore to tackle these important issues. So there's plenty of opportunities to develop fascinating scientific research based on these problems with a very large suite of scientific knowledge to solve these problems and to tackle the challenges of the sustainable development goals. But the problem is how Latin America is allocating resources and budgets to science and technology. As we can see in these two plots, we can see that, for instance, the largest budgets in scientific research and development in Latin America come from Brazil and Mexico and Argentina, perhaps. And these are these are the largest in the region. The other countries are way behind those three countries. But in terms of comparison with the rest of the world, Latin America is behind, very well behind of the rest of the countries of the world, especially the global north. We can see in the two view graphs that our budgets in terms of in specific terms and in figures, but also as a portion of the GDP, is very meager. So if Latin America has to understand that science is a prerequisite to leave poverty, to leave underdevelopment, to leave dependency, and to start creating a very powerful economies in terms of the most important asset that we have in Latin America, which is biodiversity. So that's the reason why we need to put many resources to develop the bioeconomy as a new paradigm of development in the continent, because this is our most important and comparative resource with respect to the other countries of the world. But without funding properly science and development and technology, we are not going to reach those goals. So I'll stop here. Thank you.
Thank you, Germán. Juan Fernando.
Yes, thank you. I would like to add something in the direction Germán was talking about, which is that I was trained as an engineer, and one notion I remember from my training is that we could solve almost every problem with steel and concrete, and if the problem is very hard, then we just need more steel and more concrete and things like that. And the city where I live, in Medellin, in Colombia, was talking about rivers, which is one of my main scientific interests. This city was built on the idea that we should build channels everywhere, trying to control the rivers. We now know that if we want to tackle problems related to climate change and the environmental crisis, we need to use a more complex approach. And this more complex approach needs to combine scientific fields and needs basic science like biology, ecology, hydrology, and things like that. We cannot control nature. We in many cases we have to understand nature, and we have to find ways to adapt to this changing world, using a combination of solutions that are not only based on engineering, like I was trained, but also based on nature, of course, and on people too. This is something I knew from the people, from some people here in my city. They used to talk about solutions based on people, not only on nature. And this requires combining all types of science. So if we are going to solve these problems, and if we are going to adapt to climate change, we have to change also our way of conceiving our solutions. In many cases, we have to challenge ourselves. In many cases, I have to challenge my training all days. Now I'm more like a scientist, not an engineer, or I would like to be, but okay, thanks.
Thank you. Graciela, you want to add anything?
Yeah, what Juan just mentioned is true. We have to think. We have to change our way of approaching the solution of the problem, but also our funding offices need to somehow respect a little bit the need for basic science. Many governments are, for example, requiring that your research necessarily has to solve a problem. We can try to solve, we can think about possibly solving a problem, but we need to start with basic science. We need people trained in basic sciences, biology, mathematics, physics, and chemistry, and strengthen our undergraduate degree programs, which I think in general are very good, and I keep strengthening our graduate degree programs that recently I think probably are not getting the resources that we need. So yeah, as Juan mentioned, we have to think, we have to change a little bit the way that we approach the solution.
I think that's a very important point, to change our ways of doing things. Someone said that the world is going to be there for a long time. What we're trying to do really as human beings is to destroy ourselves. The world is not going to be destroyed unless there is a terrible disaster. But as far as we can tell, the earth is going to continue. The ones that are not going to continue is us as human beings, and we have to change them. We have to insist on that first and foremost with the governments. As all of you have mentioned, unless there are enough resources to do science, it's very difficult to progress and come close to the other countries, especially, as you say, in the global north. Although I like to mention the fact that in meeting that I was recently, the expression global north and global south expressions were being challenged. Why? What is the global south? How do you define it? In my opinion, it's just a way of not calling us underdeveloped. Someone invented global north and global south. Yes, Germán, you have your hand.
Thank you, Rick. No, I just wanted to add something about what Juan Fernando and Graciela referred to, which is the need, of course, the need for appropriate budgets is very important in Latin America, but also the need for proper perspective on what to fund. For instance, in Colombia in the last decade or so, there was some fashion to fund projects associated with the development of patents. Of course, this is very important, but the government didn't understand that for you or for us to have patents, you have to cover all the bases from the basic science, biology, nanotechnology, physics, chemistry, ecology, all the sciences, even mathematics, of course. Mathematics is very important, and statistics. So the government has to understand that in order to have patents, we need to cover all the bases, all the way from basic science to applied science, to technology, to engineering, and to the development of patents. So the need is not only for good, proper funding, but also good and proper and adequate policies about the funding of research. Because as Graciela was saying, of course, we need to develop basic science. Basic science is the most important, is fundamental for this change, linking scientific research with the production of patents.
This is really what the International Year of Basic Science for Sustainable Development is trying to do. It's trying to emphasize on governments and people in general that basic sciences are important for sustainable development. And you have mentioned it, all of you have mentioned different aspects in which basic sciences are important, are necessary, and we need to continue fighting for a different way of approaching science in our countries. This business of basic versus applied doesn't work. That's not the way, as Graciela said. You know, in many instances, or in most instances, at least in Colombia, funding comes only if you say in your proposal that you're going to discover something, that you're going to solve some problem, and that's not the way science works. This works. It takes time. It takes a lot of thinking, a lot of experimentation. It's not like from one day to the next you're going to have a result, a product. So that's particularly important. I want to ask you something. I know that Graciela has a strong involvement in this, but I don't know about the other two. With the Caribbean, how much do you work with the islands of the Caribbean, and is there any sense that things are being done there, or we still need to get closer to those islands? I know Graciela has important efforts going on in Jamaica, for example, and I have to say that the liaison committee of the Focal Point was we were in the Dominican Republic a few weeks ago, and we were impressed by the science that is being done in the Dominican Republic. So maybe this is something that we have to look into and see how we can collaborate with them and work more closely with them. Again, we realize that languages are always seem to be a barrier, but most people in most regions speak English. So we just have to, I just want to know what your opinions are, particularly Germán and Juan Fernando, because as I say, I know that Graciela is involved. Yeah, Graciela is involved everywhere. You saw not too long ago, she was involved in South Africa. So, crystallography is really important world.
Yes.
No, Enrique, this is a very important issue because, you know, in my field in climate change, for instance, there was a fundamental problem with the Caribbean, is that they belong to another chapter of the IPCC reports. They don't belong to Central and South America. They belong to the small island chapter. So they are like a completely different continent with respect to Latin America, which I think is a mistake, because, I mean, we're very close neighbors. We shared many of the same problems and many of the same consequences associated with climate change. But I think it's a mistake, because that way we are not speaking to each other, and the gap between the science and the solution is going to increase with the years. So I think we need to break that barrier, and we need to struggle to be part of the same continent, because we are part of the same continent. But as you said, the language barrier nowadays is not an excuse for trying to reach this to bridge this gap between Latin America and the Caribbean, because as you said, I know very important science being developed in many of the island of the Caribbean. So we need to overcome this limitation.
Thank you, Juan.
Yes, I just have to say that I would like to, but I haven't collaborated with colleagues from the islands in the Caribbean. And now that you ask that, I don't really know why, because they are so close. They are, yeah, maybe it's part also of the things I have to change in my mind. I most of the time look to other, to Brazil, to Venezuela, to Ecuador, Argentina. I don't know, maybe it's part also of my setup.
Right.
Definitely, as you can see, I have a bad cold, but definitely we need to work more south to south, relations between ourselves and in other countries in the southern part of the world. We all tend to have our collaborations with the US or England, but anyway, it's important, and I am glad I asked the question, because I'm even more glad that you agree with me. We need to bring. Graciela, you want to add something?
Yeah, no, I agree. And we usually refer to Latin America as only the countries in the continent. We usually do not include the islands, and we have to look at the Caribbean as a whole region.
Yes, I agree. One last question, which is a little problematic to answer, is: do you really think, each one of you, we still have a few minutes, that the Sustainable Development Goals are going to be fulfilled by 2030? How do you see that in your own regions, countries?
Well, Enrique, I would say that I am very pessimistic in that regard, and somebody said that a pessimist is a well-informed optimist. So, but I don't think, especially because of the pandemics, COVID-19 delayed all the economic progress worldwide, and especially in our countries. And this has impacted all the issues associated with the Sustainable Development Goals. So we need, perhaps the UN system should convene to redesign or to rethink the timeline for the reaching of the goals, a realistic one that considers all the problems that the pandemic caused all over the world, not only in terms of economic burden, but also in all the problems that it caused to the supply chain of many services and goods all over the world. And so therefore, the United Nations system has to be honest, I would say, in a good sense, to redefine the timeline for the reaching of the Sustainable Development Goals, not only because of the lack of progress in many of those challenges in the global south, in the developing world, but also for the challenges and the impacts brought about from the pandemics.
Thank you, Graciela.
Yeah, I also think it would be difficult to completely fulfill the goals, but perhaps I'm sure some countries will approach closer to the goal than others, and that's something that we have to try to correct and help all countries to try to go in this pretty much in the same direction, and also to have a consistent development throughout the years, and because it's going to be difficult, but with the help of the countries such as Brazil, Argentina, Mexico, that have longer traditions, Chile, and more established societies that can be involved in all these issues, help other countries to progress and try to reach the goals that we want to reach.
Thank you, Juan Fernando. Very quickly, I have to ask the organizers how this ends. Yeah, go ahead.
Yeah, I'm trying to be optimistic despite the difficulties in the problem. And one thing I just want to say is that I'm hoping for kind of a tipping point. We are used to think that tipping points are bad, but not necessarily. Maybe we need kind of a tipping point, not in nature, but in the society. And I think this tipping point in the society is likely. And if it happens, maybe we can make the changes in the society we need to tackle these problems, because we have the solutions, we have the understanding, we have the science. We are not solving the problem, not because we don't have the solutions, but because we cannot change human beings' minds, things, changes in the way of thinking. So we need a tipping point in social things, and I have hope in new generations. So just trying to be optimistic.
Yeah.
As a member of the Young Academy,
Yeah.
not surprised what you just said.
Despite I'm not so young.
Enrique, let me finish to say something that I think is important at this point. We as scientists we need to defend our profession. In this time, we are facing very, very threatening, very worrisome threats from the anti-science movement, from the dispersers of fake news, from the tierraplanistas. How do you say that?
Flat earthers.
Yeah. Trumps, from the Bolsonaros, from the like. So we as scientists in the developing world, especially, we need to defend our profession, and we need to defend science as the basis of all our progress. So in this area of this amazing denial of science, the denialism of science, we need to defend our profession.
Thank you. I have to ask the organizers, how do we end this? Did you just cut us off, or?
All right, you still, in theory, you still have 10 minutes if you would like to continue discussion with one additional question or any closing remarks.
That's wonderful. Thank you, because I think there are more things that we want to say. Thank you very much. Yes, I'm sorry that we ran these last few minutes and thinking that it was going to stop at 35, but if we have 10 more minutes, then we are open to more conversation about all these issues.
I would like to expand my answer.
Go ahead.
Yeah, because I was saying that I try to be optimistic. It's very hard, but another reason to be optimistic is that now the new generations, climate change is not new for something new, something that appear for the new generations. The most important people making decisions nowadays knew about climate change during their life. Of course, there are many people that want to change, to make important changes, but new generations that will be in charge in, let's say, like 10 years or so, grow with climate change and know, I think they know better than former generations that their future is really compromised. I just read a paper recently published by the group of Tim Lenton from the University of Exeter, just saying that a big part of Colombia will become uninhabitable if we reach 1.5 Celsius degrees in climate change. And it's very likely that we will reach that limit in the next decade. So we are talking about big parts of Colombia becoming uninhabitable in like 10 years. So it's very hard to be optimistic facing this scenario, but we have solutions, and I think people is changing, and people can change, and people will eventually change for one or another reason. That's what I think.
Yeah, no, I just wanted to mention, you can be optimistic, but you can also be realistic at the same time. So I'm optimistic. I know we can achieve many things, but well, the reality tells us that it's not going to be at the same pace as the global north, unfortunately. But we will certainly make our best effort, and we have to make our best effort to make the changes that we need to make, so that we will be in the spotlight. Because as you have mentioned, we have many resources, we have expertise, we have a long tradition in different areas, in basic sciences and in advanced sciences. So we can do it. So I'm cautiously optimistic, you can say.
Somebody suggested that maybe the word goals should be changed by objectives. You may or may not reach an objective, but goal is that's it.
Yeah.
There. So but that's the name. You'll be interested to know, of course, that the group that has organized the International Year is now working on a decade of basic science for sustainable development, and is going to be presented to UNESCO as an idea to have 10 years of this general idea that is being developed through this International Year. So, and that they're working very hard on getting that approved by UNESCO. So that's good news in that respect, that we continue to. But the problem, or one of the problems here, is that we have many, as they say now, stakeholders involved. One is governments. If governments don't interiorize, don't accept the fact that this is important, then that's the first problem. The second problem is the scientific community. And I was going to ask you, if we had time, I'd like to ask you, but let me just give you this other. So government, scientific community, funders, and the social society, the civil society. And unless the government and all these other organizations try to really sell the idea of the Sustainable Development Goals to the society, what the change that Juan Fernando is talking about is going to be very difficult to achieve, because people don't want to change the ways of doing things. We're very happy taking the car and driving to the drugstore next door, you know, and this is something that needs to change. And hopefully, as you say, maybe that will happen. Maybe we will get to that point, but you know, and be optimistic, as you all said, about this. And so, yes, Germán, you wanted to add something, or?
No, Enrique, thank you very much.
Well, I I would just say that there are a few things that I picked up as you were speaking, and that I'd like to refer to them. One is the importance of bringing together social sciences and natural sciences. That's the reason for being of the International Science Council. As you probably know, the ISC was created by precisely uniting the International Union of Scientific Unions, the International Council of Scientific Unions, and the International Council of Social Sciences, ISSC, bring them into one organization, which is the International Science Council. That's an important step forward. It started in 2018, but it has to become like part of our vocabulary all the time. Let's put together these two things. And in addition to that, what Germán said is making sure that traditional knowledge is included. In my opinion, we have included it historically, but maybe it is not as noticeable. We all know, those of us who have done field work, know that there's a lot of information that we receive from people even without asking. They are there to give us information, what they use things for, and so that has to be increased without going to the extremes that that's the only thing that is important, and that because the traditional knowledge exists, then the science that we do is not necessary, and that's very dangerous, and it's something that we have to be very careful about, and be really in the lookout for that kind of attitude. So that's one thing. The other thing is what you mentioned, Graciela, of the natural products. That's terrifying, you know, to know that there are so many things being sold to people, telling them that they're something that they are not. And so the kind of research that you're doing and the way you put it together with the development goals, it was very clear and very obvious that's what needs to be done. We need to be very careful about what the pharmaceuticals we use and whether they have been carefully studied and whether we know exactly what they're telling us that they do, what their compounds are, because it is. I remember a professor of the National University here in Bogota doing that at a local market, going asking people what they were selling those plants for, and then having them studied at the chemistry laboratory at the National University, and some things came out that were not particularly nice. The need for resources, we all know that. God, I wish we could sell that idea to the governments. You know, what Germán said of us having the lowest percentage of gross the GDP in the whole world. We can't get anywhere when most countries in Latin America are below 0.5. Most. Argentina is at 0.5. Cuba says that they are 0.6. I have to believe them, but Brazil is 1.1, and the rest of us are way behind. There are countries in Latin America with 0.03% of GDP in science and technology. So that's really bad news. And the science we do is so good with such limited resources that the rest of the world has to understand that and has to start working with us. One of the ideas that I am defending at the international or union meetings is stop talking about capacity building only. When you are in an international organization, you tend to think of these countries as countries that need to be taught what to do, and they have to come here and tell us and teach us things. And I keep telling them there are many things, just like the indigenous knowledge. There is so much that we can teach them, because we're in a country like Colombia where we have everything that most people don't have. So they have to start working with us, recognizing our capacities, recognizing what we have. I'm not saying that fellowships are not good. They are always good, no matter who gives them, they're good. But we have to start, and I said that last week. I said we have to start including the word networking, not just capacity building, because that has a meaning that I basically don't like. Herman.
Yeah, last idea is that we need to bring another stakeholder into the fore, which is the private sector and the businesses. All over the world, the expenditure of the private sector in scientific research, basic scientific research, is very huge. And in many countries, the portion of the investment in science and technology by the private sector is even larger than the government. So here we need to bring in this other stakeholder, the private sector and the businesses, to fund scientific research, even basic scientific research.
Research has been done as in regards to how much does the government have to invest before the private sector begins to put money into this, and it has come to about 0.8% of the GDP. When the country starts spending 0.8, and that has happened in Finland and happened in New Zealand, so it's a good point to keep in mind for this kind of thing. But we have to start talking to them, and some of them already do a few things, but yeah, that's important. Transdisciplinarity and interdisciplinarity is another thing that we need to start working. Unless the chemists and the physicists and the biologists and the mathematicians start talking to each other, we're going to be stuck, not being able to do a lot of things. So those two terms are very important, and the future of our world depends on how we work together, and you all put that very clearly in your presentations. The change of approach, let's finish with that. We need to change our approach to life. We need to change our approach to how we use our resources, understand, accept, and believe in the fact that in the case of Colombia, but most tropical countries in the Americas, we're very rich in what we can offer. We're rich in what we can take advantage of, we can use really to the advantage of our countries and to the economy of our countries, and stop thinking about just one or two ways of getting. But again, energetic transition or transition of energy doesn't happen from one day to the next one. Just like everything else, things don't happen from one day to the next. It's going to take time, and we have to understand that. We have to think that we have to move. We have to understand that we have to move in that direction, but we cannot do it in 3 years. Believe me, you cannot leave oil and coal out of the question in 3 years. That doesn't work. But anyway, thank you very much, all of you. Thank you to the International Year for giving us this opportunity. I again apologize for being late. It was the fault of the link, not my fault. I was sitting here since 3:30 waiting to start. But anyway, thank you. Thank you very much.
Thank you very much.
Thank you all the panelists, and thank you the organizers for this opportunity. Who am I talking to?
Thank you.
Thank you so much to all of you, to Enrique, Herman, Graciela, and Juan, for this incredibly inspiring discussion. And I have to say, I'm really, really happy that you joined us today to celebrate the common cause that I think many countries around the globe are sharing. So thank you again.
Okay.
And now we will move on with the program. So now I am pleased to present the Science Action Video Contest winners. This year's NSERC special edition of the contest celebrated the International Year of Basic Sciences for Sustainable Development 2022. And the 6 winning videos help put science and engineering in Canada in the spotlight to show how research is improving lives all around the world. So let me share the video with you.
On the occasion of the International Year of Basic Sciences for Sustainable Development, the Natural Sciences and Engineering Research Council of Canada and the Fonds de Recherche du Québec Nature et Technologie joined forces to organize a special edition of the Science Action Video Contest.
The contest challenges members of the research community to help Canadians discover how science and engineering contribute to our understanding of the world and universe around us by documenting the people, research, and innovations that are transforming the way we live and work.
Basic science research is essential for better understanding and addressing major societal challenges, such as climate change. It also provides tools for better decision-making and the fundamental skills for training the highly qualified workforce that will find ways for a better and sustainable future.
Universities and colleges in Canada play a central role in finding ways to address and achieve sustainable development goals. This special edition of Science Action was open to graduate students who are currently working or who have worked on research funded through an NSERC or FRQNT grant.
Participants were invited to submit a 1-minute video showcasing the research. We received videos from across the country.
All video submissions highlighted the benefits of research in the fields of natural sciences and engineering by making the connection between basic sciences and the Sustainable Development Goals.
It is an honor for us to present the 6 winners of this very special edition of Science Action.
We are certain that you will enjoy these videos as much as we did, and we encourage you to share them with your families, friends, and colleagues.
Due to population growth, industrialization and climate change, the world is expected to face water crisis. Desalination and water recycling are potential solutions. Membrane technology is the most energy efficient technique among all water purification technologies. Membrane as the main part of this system separates salts and impurities. Advances in membrane materials are needed to improve the efficiency of water purification systems. At the University of Waterloo, Applied Nanomaterial and Cleaning Lab, by using nanotechnology, polymer science, and computational chemistry, we developed a hybrid selective layer with a thickness of 20 nanometer, 5,000 times thinner than human hair. This novel tube membrane filters dirty water twice as fast as traditional membranes, resulting in a more efficient purification system. This research significantly contributes to the achievement of the Sustainable and Development Goals for clean water and sanitation and other cross-cutting themes.
L'échographie est une méthode d'imagerie médicale qui utilise des ultrasons, soit des sons inaudibles pour l'humain. Pour produire une image, on émet des ultrasons avec une sonde, puis on mesure la réflexion produite à la rencontre d'un obstacle, comme un visage. Toutefois, la qualité de l'image produite n'est pas toujours optimale, car elle dépend grandement de la sonde utilisée. En effet, plus notre sonde a de transducteurs pour émettre et mesurer les ultrasons, plus on pourra construire une image de qualité au détriment de la vitesse de calcul. Comme solution, le CRASH travaille à développer une sonde échographique munie d'un masque de codage, ce qui permet de déguiser la sonde en une sonde qui a plus de transducteurs. En fait, un masque de codage est une lentille à la surface très irrégulière qui déforme les ultrasons et enrichit le signal mesuré. Cela permet de réduire le nombre de transducteurs pour produire rapidement une belle image. Différentes formes de masques de codage pourraient même servir à élargir le champ de vision de la sonde, un autre effet des masques de codage qui aide la santé des humains et réduit les inégalités médicales conformément aux ODD de l'ONU.
Les forêts canadiennes vont faire face à beaucoup de problèmes. Il va y avoir plus de feux de forêt, plus de sécheresse, mais aussi des épidémies et des espèces invasives. Et tout ça risque de réduire leur fonction importante pour la planète. Il y a peut-être une chance de les aider à s'y préparer. C'est le but des recherches menées par notre équipe à l'Université du Québec à Montréal. Notre mission, c'est de regarder si on peut diversifier les forêts par l'aménagement forestier et voir si cela peut préserver leur fonction dans un futur incertain. Pour ça, on utilise des modèles informatiques de pointe pour prédire comment les forêts vont évoluer. On varie la manière dont on les gère, le climat, et on leur fait subir des catastrophes pour voir comment leur fonction perdure dans ces différents scénarios. On simule au total 4 millions d'hectares de forêts québécoises dans 240 simulations différentes. Un travail de titan réalisé par les superordinateurs canadiens accessibles aux chercheurs. Il y a de l'espoir dans la lutte contre les changements climatiques. Mais on doit préparer les forêts à un monde qui va changer.
You've probably heard of HIV, a virus that leads to a dangerous weakening of the immune system called AIDS. And while there are effective treatments against this infection, there is still no cure because HIV can lay dormant for years and cells infected with a dormant virus are not eliminated by anti-AIDS medication because they look just like healthy cells. The problem with dormant viruses is that they can wake up if treatment is interrupted and cause irreparable damage to the immune system. HIV becomes dormant through different mechanisms, one of which involves a pause in its production. I'm studying the possibility of awakening dormant HIV by overcoming this pause with the help of the hepatitis delta virus, or HDV. HDV produces a small protein that has shown very promising results in overcoming this pause in production when used on dormant-like HIV in the lab. By awakening dormant HIV with this HDV protein, or a similar compound, we aim to make the healthy-looking infected cells finally be recognized as infected and eliminated by the anti-AIDS drugs.
Ammonia. Today, ammonia is one of the most important chemicals in Canada and the world because of its use in many sectors, but most of all, fertilizers, which are vital to much of the food we eat. Furthermore, ammonia is of interest as an energy storage by itself or as an energy carrier for hydrogen. This is valuable as there's a necessity for better energy storage options in a cleaner future. Ammonia is produced by combining hydrogen and nitrogen. However, the overall process generates a lot of greenhouse gases because the hydrogen is often produced using fossil fuels. To help Canada's efforts to meet the UN Sustainable Development Goal of taking urgent action to combat climate change and its impacts, my research alongside the Greener Production Group at the University of Waterloo will be about greener ammonia production. This research aims to help reduce greenhouse gas emissions which are connected to climate change. I'll be performing a cost-benefit analysis on the greener ammonia production alternatives, such as carbon capture systems and electrolysis. I will be using both engineering and economics techniques. The output of my research would be a suggestion on what Canada's ammonia production and industry should look like in the future.
Part of UN Sustainability Goal 3 aims to promote mental health and well-being. The COVID-19 pandemic and the social isolation it caused have highlighted the important role that social bonds play in our mental health. In our lab, we examine the neural pathways and mechanisms that enable us to form social bonds by studying pair bonding in zebra finches. Zebra finches are songbirds that form lifelong pair bonds which can be expressed as a preference for their mate's song. These preferences are partly mediated by dopamine neurons, which are also known to play a role in pleasure, motivation, and learning. These neurons send specific signals to higher-order sensory processing areas in the brain that are important for memory, recognition, and preference. Our lab's current research focuses on the role that dopamine neurons play in the formation of a female's preference for their mate song and the consequences if these signals are lost. Our findings will shed light on the role that dopamine plays in forming preferences in order to understand the underlying neural mechanisms that define social bonds, ensuring better mental health and promoting well-being for all ages.
Our congratulations to all of the winners of the competition. And now I would like to introduce Diego Gaman Lamas from Argentine National Research and Technical Council, CONCINET, who is joining us here today from Argentina. Diego will give a talk in Spanish on inspiring scientific vocation in high school students, the experience of the Argentine crystal growing contest. Diego, please take it away.
Thank you, Monica. Bueno, voy a cambiar entonces a español. Muchas gracias por esta oportunidad de compartir esta experiencia de la Asociación Argentina de Cristalografía para la promoción de vocaciones científicas, para despertar vocaciones científicas en los jóvenes. Posiblemente ustedes saben que el Año Internacional de las Ciencias Básicas para el Desarrollo Sostenible es impulsado por muchos organismos de uniones de ciencia, como la UPAP, la UPAC, pero también la Unión Internacional de Cristalografía, y esta es una iniciativa que viene de la mano la Unión Internacional de Cristalografía y de la Asociación Argentina de Cristalografía. Les voy a contar una experiencia que ya lleva 10 años y nació en el Año Internacional de la Cristalografía en el 2014. La Asociación Argentina de Cristalografía es una asociación muy joven, nació en el año 2004, así que en el momento en que comenzamos esta experiencia de lanzar una actividad para promoción de vocaciones científicas y difundir la cristalografía, principalmente bueno, en nuestro país, en Argentina, en el Año Internacional de la Cristalografía, que fue el año 2014, la asociación apenas tenía 10 años. Y bueno, era un lindo cumpleaños también, al mismo tiempo que se celebraba a nivel mundial, en ese momento, otro año internacional, el Año Internacional de la Cristalografía. Posiblemente no es una ciencia tan conocida, pero lo que tiene de lindo es que es bien interdisciplinaria. Por un lado es medio complejo encontrar cristalógrafos, porque a nivel mundial no hay carreras ni de grado, ni incluso de posgrado de cristalografía. En algunos países hay algunas maestrías, pero es muy raro encontrar ese tipo de carrera. Entonces es un desafío para nosotros en este campo difundir esta ciencia. Es la ciencia que estudia los materiales sólidos, principalmente cómo es el ordenamiento atómico de los materiales, principalmente para entender las propiedades de los materiales. La mayoría de los materiales sólidos que nosotros tenemos en casa todos los días, que usamos para casi todas las cosas, la mayoría tienen átomos o moléculas ordenadas y nos permite esta ciencia entender sus propiedades. Y aprovechar este año internacional era un desafío importante. Y nuestra idea no era solo difundir la cristalografía, que por supuesto era la idea y llevarlo a toda la sociedad, igualmente que este año la idea es llevar las ciencias básicas a toda la sociedad, sino también el método científico, el pensamiento científico y la ciencia en general, tratar de compartirla con toda la sociedad. Y a nivel mundial se propuso la idea de tener un concurso mundial de crecimiento de cristales y que los países que estuvieran interesados organicen concursos nacionales. Y ahí lanzamos este concurso nacional de crecimiento de cristales, este concurso argentino de crecimiento de cristales, como les digo, en el año 2014. Y por suerte lo pudimos sostener todos los años, hasta hoy, a pesar de la pandemia y a pesar de las dificultades económicas y distintas complicaciones que hemos tenido a lo largo de los años en nuestro país y a nivel global, ¿no? Que ustedes saben que hemos pasado momentos muy difíciles. La idea no es que todos los chicos salgan fanáticos de la cristalografía como tal vez somos algunos de nosotros, tampoco la idea es que todos salgan grandes científicos, pero sí que se acerquen a la ciencia y que se den cuenta que la ciencia está en casi todas las cosas que nos rodea y que traten de animarse a descubrir lo divertida que puede ser y que la podemos hacer en la escuela o en casa con las cosas que tenemos a mano. Entonces nos pareció una linda posibilidad la de crecimiento de cristales para, por un lado, acercar a los jóvenes a los sólidos, a los materiales, a la cristalografía, por otro lado, acercarlos también a la física y a la química a través de estos experimentos de crecimiento de cristales. ¿Qué es lo que pueden hacer los estudiantes que participan? La idea es orientarlos a algunas sustancias que sabemos que no son peligrosas y que sabemos que son relativamente fáciles de conseguir y económicas. Aquí en Argentina, yo digo económicas, y hasta un paquete de azúcar es bastante caro, estamos en momentos difíciles, pero bueno, eso es algo que está en todas las escuelas y que los estudiantes pueden trabajar. Y tengo algunas cosas para mostrarles, pero por ejemplo podemos hacer cristales de azúcar, digamos así, con formas simpáticas como puede ser un palito de azúcar, en este caso con un colorante. ¿Vieron esos colorantes que se usan para tortas? Yo tengo acá algunos en casa, se van a dar cuenta que me la paso jugando en mi casa, ¿no? Estos son, por ejemplo, es un palito de esos que se usan para atar carne, ¿no? De brochette, decimos acá. con cristales de azúcar, con colorantes, podemos hacer algo tal vez de interés artístico, pero también podemos crecer cristales más grandes y hacer un estudio científico, por ejemplo, crecer también azúcar, pero de cristales mucho más grandes, espero que se esté viendo. Y fíjense las geometrías bien definidas que tienen los cristales de azúcar, ¿no? Las características de cualquier cristal, de cualquier material con átomos o moléculas ordenadas. En este caso de azúcar, moléculas de sacarosas ordenadas. También podemos hacer, esto es lo que en cristalografía se llama un policristal, un conjunto de muchos cristales, pero también podemos hacer lo que se llama un monocristal, un cristal, como si fuera un lingote, ¿no? Bien, con geometrías bien definidas, espero que lo estén viendo, caras lisas, ángulos bien marcados, geometrías bien perfectas. Esto es característico de los cristales, de cualquier material en que tenemos un orden atómico. Entonces, proponemos que los estudiantes trabajen con azúcar, con sal, con distintas sales o sustancias que sean relativamente simples de conseguir, económicas, y que no sean peligrosas, eso es importante. También sabemos que son sustancias, estas 6 que ven aquí, que los alumnos pueden abordarlo sin tengan una dificultad extrema, aunque algunos tienen sus complicaciones. Si quieren darles algún color, podemos usar estos colorantes, como les decía, de tortas o colorantes vegetales o tintas, pero bueno, de nuevo, nada que sea peligroso. Y pueden hacer entonces o monocristales o policristales, y a través de eso hacer un trabajo científico, porque por ejemplo, para llegar a cómo crecer, por ejemplo, este es un fosfato, se llama KDP, un fosfato, cómo crecerlo en mejores condiciones, y que bueno, que tengan dimensiones grandes y lo más perfecto posible. O el que veíamos de azúcar, o por ejemplo este es otro material que crece bastante grande, sulfato de cobre. ¿Cómo hacer los cristales más perfectos? ¿Cómo hacer que crezcan lo mejor posible? Otros piensan, bueno, yo quiero lo más grande posible. Bueno, eso es un trabajo, un desafío científico que los estudiantes lo pueden abordar con lo que tienen en casa. ¿Cómo podemos hacer cristales? Y a través de lo que en química se llaman soluciones sobresaturadas, uno puede lograr que precipiten cristales según cómo lleva adelante el proceso, y los puede ir creciendo. Puede tener pequeños cristales y irlos creciendo en soluciones sobresaturadas. Entonces podemos hacer, como ven aquí, monocristales o policristales con distintas formas, o policristales simplemente grandes, y bueno, y estudiar cómo es el proceso de crecimiento, pero también con distintas formas, y llevar un mensaje o alguna obra de arte o lo que sea. Entonces pueden crecer monocristales o policristales los estudiantes, y pueden también hacer trabajos que sean combinando sustancias por alguna propuesta de interés artístico o tecnológico, también pueden combinar esas sustancias. Entonces esas son las distintas propuestas, pero siempre las 6 sustancias que les había mostrado. Y la idea entonces es que lleven adelante experimentos de química simples. Estamos hablando de preparar soluciones sobresaturadas y controlarlos, ya sea para generar monocristales o para lograr policristales. Y bueno, que ellos pueden desarrollar métodos propios para llevar adelante. Entonces, ¿cuál es la idea de esta propuesta? Que los estudiantes de forma divertida se acerquen a la ciencia, al método científico, siempre con la guía de los docentes. La propuesta que llevamos adelante en la Asociación Argentina de Cristalografía, y que en realidad nació inspirada de un concurso nacional de España y otros concursos que había antes de esta propuesta que lleva adelante nuestro país, y que acá en América del Sur también hubo otros concursos con los que hemos tenido oportunidad de intercambiar información en Uruguay y en Chile. Todo arranca con capacitaciones para los docentes. La idea es que los estudiantes trabajan en sus escuelas con sus docentes, con la guía de sus docentes. Entonces empezamos la actividad de todos los años, siempre haciendo talleres de capacitación docente. Los acercamos al mundo de los cristales y hacemos una introducción a qué es la cristalografía, cómo son las técnicas que se usan en cristalografía para entender el orden de los átomos en los materiales. Vemos las técnicas de rayos X más importantes de nuestra ciencia, la difracción de rayos X, y luego abordamos las técnicas de crecimiento de cristales y le planteamos las propuestas de participar en el concurso nacional de crecimiento de cristales y en el concurso mundial de la Unión Internacional de Cristalografía. Entonces, los docentes, una vez que toman estos cursos, estos talleres de capacitación, llevan este tema al aula, lo presentan a sus estudiantes y los estudiantes empiezan a diseñar sus experimentos, su propuesta, y realizan un trabajo de crecimiento de cristales, que lo pueden realizar en grupo o en forma individual. Si es en grupo, en máximo 3 estudiantes para que todos tengan un rol protagónico en el trabajo. Y bueno, preparan un video o un informe con básicamente la estructura de cualquier trabajo científico para presentar ese trabajo, y eso lo envían a un jurado que evalúa los trabajos. Para fin de septiembre, casi todos los años es esa fecha, el jurado presenta los trabajos que selecciona para una jornada de finalistas y también destaca una cantidad de trabajos con menciones especiales que también se invitan a la jornada de finalistas para que se compartan los estudiantes sus trabajos con los demás estudiantes de otras escuelas. Argentina es uno de los países más extensos del mundo, no sé exactamente en qué orden está, pero debe estar no sé, el orden del 10º o algo así en extensión. Tiene, además del Distrito Federal de la capital, en Buenos Aires, hay 23 provincias, y bueno, con algunas muy al norte muy cálidas, otras muy frías al sur. Y bueno, todas las 23 provincias las hemos recorrido muchas veces. Estos talleres de capacitación docente, con distintos colegas de la Asociación Argentina de Cristografía y con los coordinadores y el comité organizador del concurso, lo hemos recorrido muchas veces, presencialmente, y también hemos hecho últimamente algunas actividades virtuales, pero hemos por lo menos ido en promedio una vez por año a todas las provincias, y de esa forma hemos logrado que sea una actividad bien nacional de todo nuestro país, no de unos pocos aquí en la capital del país, tampoco en las capitales, tampoco es para las capitales de las provincias, la idea es que sea para todas las localidades, que queremos que la ciencia, el método científico, el pensamiento científico, la cristalografía, la física, la química lleguen a toda la sociedad, y por eso recorremos todo el país. Y la jornada de finalistas que hacemos es siempre con participación de estudiantes de todo el país, y es siempre una alegría tener estos eventos donde los estudiantes comparten sus trabajos. Como les decía, entonces son trabajos que pueden ser videos o informes donde se muestran los cristales y se cuenta todo el trabajo desde el punto de vista científico, aunque muchas veces tienen objetivos artísticos también. Acá ven algunos o sea, en el año pasado, las localidades por donde pasamos, donde hicimos los talleres, recorriendo todo el país. Ya llevamos desde 2014 hasta ahora más de 300 talleres de capacitación docente. Son talleres del orden de 4 o 5 horas, donde compartimos todos estos temas. Aquí algunas fotos de estos talleres. Y como les comentaba, el programa que tiene es primero ver una introducción a cristalografía, después el crecimiento de cristales y después compartir la propuesta de cómo llevar la temática al aula. Pero bueno, para cerrar la charla les quería mostrar algunos de los trabajos que hemos recibido a lo largo de los años, para que vean un poco el alcance que ha tenido, el tipo de trabajo que hemos recibido. Ya de 2014, que fue el Año Internacional de la Cristalografía, fue sorprendente para nosotros, pues nosotros esperábamos trabajos más bien científicos, como pueden ser crecer monocristales, acá de azúcar o de sal, o policristales de cristales grandes, pero ya nos llegaron un mensaje de paz, el símbolo de la paz, un mensaje de paz con cristales, una rosa de cristal. Y bueno, ya de entrada vimos que iba a haber otras propuestas, que los chicos estaban expresando no solo su amor por la ciencia, sino también su amor por el arte y también sus angustias, sus preocupaciones. Este mensaje de paz tenía que ver con las guerras que había en el mundo en ese momento. Imagínense hoy en día, ¿no? Los mensajes que uno puede enviar. Y esta es la primera jornada de finalistas, solo con los finalistas esa vez, Pero ya a partir del año siguiente empezamos a invitar también a los trabajos destacados con menciones especiales, y por eso, como ven acá, ya había del orden de 130 participantes de todo el país, de toda Argentina. Y fíjense, ¿no? De nuevo, trabajos de crecimiento de monocristales. Estos son monocristales de azúcar, estos de esos fosfatos que les decía, fosfatos de ácido de potasio, KDP. Esto es hombre. Pero fíjense también este trabajo, este zapatito de cristal, ¿no? Es uno de los trabajos más destacados de nuestro concurso. Zapatito de policristales de alumbre de potasio, que se destacó también en el concurso mundial, fue medalla de oro en el concurso mundial. Y como verán, todos los años seguimos recibiendo algunos trabajos con monocristales muy científicos, con trabajos muy rigurosos. Fíjense, por ejemplo, estos monocristales de alumbre, lo transparente que son, que uno puede leer lo que está abajo. Realmente es sorprendente, ¿no? Algunos trabajos así de muy alta calidad en crecimiento de cristales y otros más bien, como ven, más bien artísticos, ¿no? Con mucha creatividad. Todos los años más o menos lo mismo. Esto es lo que aquí en Argentina se llama mate, pero yo no les recomiendo que usen un mate de sulfato de cobre porque seguramente se van a intoxicar. Aquí, como ven, joyas, y también otros trabajos mucho más técnicos, más científicos. Entonces, todos los años hemos tenido este tipo de propuestas, ¿no? Algunos más técnicos, más científicos, otros más artísticos, por ejemplo, este conejito. Y al mismo tiempo fuimos viendo cómo iba creciendo la comunidad, cómo iba creciendo la relación entre los estudiantes y sus docentes, como muchos chicos que tenían problemas para comprender química y para tener motivación para estudiar, se dieron cuenta, se fueron acercando a sus docentes, se fueron acercando a la ciencia, y se animaron muchos a seguir carreras científicas también. Y esto fue lo que más nos sorprendió. Pero también nos sorprendieron los mensajes de amor, los mensajes de paz. Chicos, por ejemplo, que tenían problemas de autismo que se pudieron comunicar mejor. Chicos que tenían problemas económicos que, bueno, que con esto se pudieron expresar sus problemas, sus angustias. Chicos con algunos problemas de violencia en sus casas que pudieron dar un mensaje a través de los cristales. Y así a lo largo de los años hemos encontrado trabajos hermosos. La pandemia fue un desafío, pero a pesar de eso decidimos seguir el concurso con una nueva modalidad que era trabajos, además de crecimiento de cristales, que en este caso en pandemia los tenían que hacer en la casa, también podían hacer trabajos de investigación bibliográfica. Y esos trabajos de investigación bibliográfica eran más fáciles, ¿no? de poder realizar. Bueno, fíjense que algunos trabajos tenían que ver con expresar la preocupación del COVID. Era el año también del centenario del nacimiento de Rosalind Franklin, y varios trabajos plantearon eso, y de paso planteamos la cuestión del lugar que ocupa la mujer en la ciencia, y este caso icónico, ¿no? de Rosalind Franklin, se pudo estudiar con mucho más profundidad y discutirlo, cuál fue toda la contribución de Rosalind Franklin, que no fue solo su aporte a la resolución de la estructura del ADN, sino también su aporte de la cristalografía para resolver estructuras de virus, que justamente son herramientas que se usaron durante la lucha contra el COVID. La cristalografía fue una de las herramientas para vencer al COVID. Como ven, también trabajos de historia de la cristalografía, empezando con Johannes Kepler, que fue uno de los primeros que tuvo la idea de la estructura de la materia desordenada al ver la forma de los cristalitos de hielo en la nieve. Y bueno, un trabajo muy, muy lindo, ¿no? Un video muy lindo de uno de los grupos que participó en este concurso. En 2021 también seguimos con esta modalidad. No pudimos hacer una jornada de finalistas presencial, pero ya el año pasado pudimos volver a la presencialidad, si bien mantuvimos la modalidad de trabajos de investigación bibliográfica, también había muchos trabajos de crecimiento de cristales hechos en las casas y ya en las escuelas nuevamente. Son las mismas categorías que estábamos comentando antes, pero también incluimos categorías que tenían que ver con los años internacionales, y una propuesta era que los estudiantes hicieran trabajos dedicados al Año Internacional de las Ciencias Básicas para el Desarrollo Sostenible. El año pasado también fue el Año Internacional del Vidrio. Entonces, bueno, tuvimos algunos trabajos muy lindos, donde bueno, la propuesta era cuidar nuestro mundo, pero También tuvimos el trabajo más destacado de los años internacionales, tenía que ver con el Año Internacional del Vidrio, que no sé si ustedes saben, pero los vidrios no son cristales, por más que la gente los suele llamar cristal, porque tiene los átomos desordenados. Y bueno, acá hay un trabajo ganador que planteó la copa que sí es de cristal, porque las copas de vidrio no son de cristal. Es una copa hecha de policristalina con cristales de alumbre. Otro trabajo de investigación bibliográfica relacionado con la importancia de la cristalografía para la salud. Así que a lo largo de los años hemos podido sostener el concurso. El año pasado tuvimos del orden de 200 trabajos. En los primeros años tuvimos 400, máximo 450 trabajos en el segundo año. Y luego por supuesto, durante la pandemia bajó el número, pero bueno, ya estamos volviendo a los números habituales. Y este año esperamos nuevamente sea un año donde los niños nuevamente se acerquen a la ciencia y a estas propuestas. El concurso mundial de crecimiento de cristales también fue una propuesta muy linda, y a lo largo de todos los años los estudiantes argentinos participaron todos los años. Fue una propuesta que acompañamos desde el comienzo, y hubo varios trabajos destacados de las escuelas argentinas, así que siempre estuvimos muy contentos de difundir esta actividad y de ver que no solo los estudiantes de escuela secundaria, que en nuestro concurso es para escuelas secundarias, sino también que se acercaban chicos de escuelas primarias. Los talleres de capacitación docente que damos son para primaria, secundaria y universidad, y con eso tenemos un público bastante amplio y tratamos de ayudar a toda la comunidad educativa de todos los niveles. Y con eso, bueno, a lo largo de los años han participado escuelas y han recibido también escuelas primarias, han también tenido trabajos destacados y han ganado incluso medallas de oro. Así que estamos siempre muy contentos de acompañar esta propuesta de la Unión Internacional de Cristalografía. Lamentablemente este concurso, que fue tan lindo todos los años, se discontinuó en pandemia. La Unión Internacional de Cristalografía consideró que no estaban dadas las condiciones durante la pandemia, pero este año se lanzó nuevamente, así que estamos muy entusiasmados de tener esta propuesta otra vez para compartir a nivel mundial. Y bueno, esperamos que todos se acerquen, no solo en el concurso argentino. Esperamos que otros países tomen esta propuesta, que también tiene Uruguay, Chile, España y otros países del mundo, y bueno, esperamos que también se acerquen al concurso mundial. Por supuesto, la Asociación Argentina de Cristalografía y la Asociación Latinoamericana de Cristalografía están siempre dispuestos a colaborar con los colegas de todo el mundo y compartir nuestra experiencia y ayudar para que esto se pueda llevar adelante en otros países. Yo he tenido la oportunidad de compartir esta propuesta en varios países de América Latina, especialmente en Bolivia, en Guatemala. Hemos podido hacer algunos talleres similares a los que damos en Argentina. Este año posiblemente también podamos hacer uno en Paraguay, y esperamos que esto se siga difundiendo, porque hemos encontrado que es una forma linda de motivar a los estudiantes, acercarlos a la ciencia de una forma divertida, que ellos vean que pueden hacer ciencia con lo que tienen en casa, porque azúcar tienen en casa, recipientes para preparar soluciones tienen en casa, y tienen recipientes de cocina donde pueden medir los volúmenes y no precisan un laboratorio de química. Pueden usar colorantes de los que se usan para torta, y posiblemente con lo que encuentren en casa, de lo que tiene mamá o papá en casa, lo pueden hacer. Necesitan algún recipiente para preparar la solución. Uno en un laboratorio posiblemente tenga un vaso de precipitados, pero cualquier recipiente de mermelada, de café instantáneo, que lamentablemente tomo mucho, sirve para preparar las soluciones. Así que con lo que tenemos en casa podemos hacer ciencia, podemos descubrir el método científico, y bueno, podemos despertar vocaciones científicas en los más jóvenes. Bueno, muchas gracias por esta oportunidad de compartir nuestra experiencia, y si hay alguna pregunta, por supuesto, estoy a disposición.
All right. Thank you, Diego, so much for this wonderful talk.
Thank you, Monica.
And now I would like to invite our next speaker, Dr. Berta Medrano, Chair and Founder of the Gaia Association. Berta is joining us today from El Salvador, and she will tell us in Spanish about ecological botanical walks, a comprehensive participatory science pedagogical approach for the empowerment of children and young people towards sustainable development. Berta, the floor is yours.
Share screen. Bueno, tengan muy buenas noches. Bueno, para algunos es de tarde, para algo otros y algo otras es de noche. Agradeciendo muchísimo el espacio que nos han permitido para compartir, digamos, esta hermosa experiencia que tenemos en torno, digamos, a algunos de los enfoques que hemos desarrollado a partir de la experiencia, vinculados a nuestro trabajo, precisamente que hacemos con la niñez, con los jóvenes, vinculados a los procesos de conservación de los ecosistemas y la biodiversidad. Y todo, digamos, o sea, los aspectos que de ahí se desprenden. Voy a ir avanzando. Un tema importante que quiero tocar antes es el antecedente. Nosotros hemos trabajado, esta experiencia que voy a presentar específicamente la hemos trabajado en lo que es la región del Trifinio, pero en el marco de nuestras dos grandes estrategias de intervención que hacemos en esta región, que es compartida por Guatemala, El Salvador y Honduras, que es una región precisamente de especial interés para los tres países y que es definida a partir de un tratado que se firma en 1986 por los tres países. Gaia llega desde el 2006 a esta región y somos parte, digamos, de todo ese esfuerzo de haber logrado también la declaratoria de la Reserva de Biosfera Transfronteriza Trifinio Fraternidad, que es parte de ese territorio trifinio que se ha declarado como Patrimonio Mundial de la Humanidad. Y también somos parte desde la conceptualización y diseño de la estrategia del Corredor Biológico Trinacional Montecristo. En ese marco, digamos, de esas dos grandes estrategias de conservación, de desarrollo sustentable, de apoyo logístico, conectividad e investigación, es que hemos desarrollado esta experiencia, digamos, en particular tenemos en otros territorios, pero en este día les voy a presentar esta. Denominada las caminatas botánicas ecológicas como una herramienta de empoderamiento para lo que es la niñez, los jóvenes, ¿verdad? Precisamente a través del enfoque de la ciencia participativa para empoderarlos como agentes de cambio precisamente y que promueven lo que es el desarrollo sustentable. Las caminatas botánicas ecológicas tienen como propósito contribuir al empoderamiento precisamente de la niñez y los jóvenes a través del conocimiento y la investigación de los ecosistemas y la biodiversidad de su territorio en donde viven, para fortalecer su vínculo precisamente con la naturaleza, pero también para fortalecer el vínculo de su identidad local. También parte de los propósitos de las caminatas botánicas ecológicas es fortalecer y potenciar, como ya dije, el vínculo con la madre naturaleza, que es central y es transversal, digamos, en la parte de nuestro enfoque, y desarrollar valores y principios de educación y cultura ambiental. De forma sistematizada para contribuir precisamente a la formación en todo lo que es el espectro de un paradigma de sustentabilidad ambiental en la población más joven precisamente de la Reserva de Biosfera Transfronteriza Trifinio Fraternidad, y es aproximadamente con 27.000 estudiantes que hemos trabajado precisamente en este territorio y con cerca de 1.700 maestras y maestros, profesoras y profesores. También aprender habilidades de observación, identificación y registro de biodiversidad y conocer los ecosistemas y biodiversidad donde viven precisamente las niñas y los jóvenes, o sea, que participan, y crear la línea base de biodiversidad y componentes abióticos de forma participativa e inclusiva con la niñez precisamente y los jóvenes. Los enfoques que transversalizan precisamente todo lo que es esta metodología o herramienta que se desprende precisamente de nuestro programa Gaia Tierra de Niñez, que es un programa mucho más grande y que dentro de este se encuentra el programa Simbiosis, y dentro de este precisamente se encuentra lo que son la intervención específica, que son las caminatas botánicas ecológicas. Nuestros enfoques es de ciencia participativa, precisamente para desarrollar habilidades precisamente y destrezas en la niñez y los jóvenes, los adolescentes, precisamente para ir despertando en ellos, o sea, el interés hacia la ciencia. Pero lo hacemos de forma práctica. Ya más adelante les voy a decir cómo es la parte de los procesos. Y también el enfoque de educación y cultura ambiental, como ya lo decía, precisamente lo transversaliza la intervención, porque no solamente es el tema de ciencia participativa, sino que simultáneamente vamos desarrollando, o sea, todo ese tema de valores y principios que tienen que ver, o sea, con toda la parte del valor de la educación y la cultura ambiental. También tenemos como enfoque el enfoque ecosistémico, con, digamos, o sea, su conjunto de principios que se complementan y son interdependientes entre sí todos estos enfoques, y el que ya les decía que es Tierra de Niñez, que es una metodología también, de hecho ya aceptada por la UNESCO como una metodología que empodera a las niñas y los niños, o sea, como agentes de cambio. No son el futuro, las niñas y los niños, pues creemos desde nuestra organización que son el presente y no el futuro, y pueden contribuir de forma muy significativa y esencial a los procesos que necesitamos, a las grandes problemáticas medioambientales y ecológicas actualmente del planeta. Esta herramienta, digamos, actúa también en 3 dimensiones: el conductual, el cognitivo y el socioambiental. Es decir, biodiversidad y sociodiversidad bajo el principio de unidad. Aquí, precisamente bajo estas 3 dimensiones, es que desarrollamos, o sea, toda la parte, digamos, de nuestro enfoque. También como transversales tenemos lo que son los derechos humanos, Tierra de Niñez, o sea, como enfoque es transversal también la sustentabilidad ambiental, y la madre tierra como eje transversal, digamos, en toda la parte del proceso de nuestra intervención precisamente con los jóvenes y con las niñas y los niños. En cuanto a la parte de la metodología específica de las caminatas botánicas ecológicas, tienen, digamos, o sea, 3 fases precisamente de intervención. Hay una primera fase que ahí es donde desarrollamos, digamos, entramos a desarrollar todo un tema de los acuerdos, ya sea acuerdos formales a nivel, digamos, o sea, de instituciones o organizaciones, pero a nivel también, o sea, de los acuerdos, o sea, ya específicos que se requiere esto. ¿Cómo, a qué me refiero con esto? Nosotros esta experiencia la levantamos precisamente de abajo hacia arriba. Comenzamos con una escuela muy pequeñita que es unidocente, es decir, que solo tiene una profesora. Estas escuelas que están en medio de la montaña, o sea que la institucionalidad prácticamente no llega ni a supervisar ahí, el Ministerio de Educación nada. Entonces comenzamos con una escuela muy pequeña. Con el acuerdo con la directora precisamente de esa escuela. Desarrollamos, o sea, nuestra primera experiencia piloto, precisamente bajo el enfoque adaptativo. Aprendimos, retroalimentamos y así fuimos levantando precisamente todo lo que es el enfoque en sí, el enfoque integral. Y luego sumamos otra siguiente escuela, luego ya fueron 3 escuelas, luego fueron 9 escuelas, luego 15 escuelas, 40 escuelas, y así sucesivamente. Cuando ya habíamos levantado un número considerable de centros escolares desarrollando simultáneamente actividades bajo todo, digamos, esta línea de trabajo y de forma sistematizada, fuimos tocando, digamos, a lo que es el Ministerio de Educación Central. Y es así como logramos un acuerdo macro con el Ministerio de Educación. En el 2018 hemos firmado un acuerdo, digamos, macro que abarca 7 grandes líneas de trabajo, Entre estas, promover todo lo que es, digamos, la investigación científica aplicada, pero de forma totalmente participativa, inclusiva e equitativa, bajo precisamente los enfoques de ciencia ciudadana y ciencia participativa. Y también promover todo lo que son los procesos de educación y cultura ambiental, es decir, todo lo que conlleva en sí la herramienta que transversaliza a toda la parte de los dos programas de Tierra de Niñez y de nuestro programa Simbiosis. Luego nos referimos con los acuerdos formales a esos, pero también las caminatas botánicas implican también generar unos permisos con las familias, con los padres de las niñas y los niños que participan, de los adolescentes y los jóvenes, porque es precisamente con la comunidad estudiantil de las escuelas públicas que hemos desarrollado con 247 escuelas todo este proceso, digamos, o sea, que parte de este proceso que les estoy contando, porque esto es solamente una línea de intervención con esta herramienta. Y luego a eso nos referimos con la parte de los acuerdos particulares, pero también entramos a todo el proceso de fortalecimiento de capacidades con el personal docente. Es decir, con las profesoras y los profesores, a sensibilizarlos, a desarrollar y a potenciar capacidades. Y eso, obviamente demanda tiempo, por eso este proceso se ha levantado, digamos, en un corto, mediano y largo plazo, estas tres fases, ¿verdad? Y luego entramos a una segunda fase, que es, ahí entramos con lo que son ya la parte con el estudiantado. Primero venimos a través de autoridades, acuerdos formales, fortalecimiento de capacidades de la plantilla docente, los padres de familia, o sea, de hecho también intervienen acá, y luego ya entramos a la fase 2 con la comunidad estudiantil. Y desarrollamos acá lo que es para hacer una caminata botánica ecológica, digamos, o sea, con un centro escolar. Entramos con el estudiantado primero a desarrollar lo que es el taller preliminar lúdico en relación, digamos, a todos los aspectos de educación y cultura ambiental, pero enfocado y aterrizado y focalizado en el territorio en particular, en este caso la Reserva de Biosfera Transfronteriza Trifinio Fraternidad y el Corredor Biológico Trinacional Montecristo. Es a partir, digamos, de toda esta declaratoria de Reserva de Biosfera y de Corredor Biológico Trinacional y Reserva de Biosfera Transfronteriza llamada La Joya de las Américas, que desarrollamos toda una identidad, digamos, precisamente hacia el territorio con la comunidad estudiantil. Aquí les contamos por qué es importante la Reserva de Biosfera, por qué es importante el corredor biológico, que ellas y ellos viven dentro de un territorio especial Patrimonio Mundial de la Humanidad y que se declaró precisamente, o sea, por su alta riqueza en biodiversidad, en sus ecosistemas, pero también por su gran riqueza en la parte, digamos, de biodiversidad cultural. Y luego tenemos un siguiente taller que se refiere al diseño de sus cuadernos botánicos, que los diseñan, hacemos arte, hacemos algo grandioso precisamente con las niñas y los niños aquí a través de todo un enfoque lúdico que conlleva la herramienta, ¿verdad? Y dedicamos toda una jornada para desarrollar, o sea, lo que son sus cuadernos botánicos y de biodiversidad que utilizan cuando realizamos, o sea, ya las caminatas. Y luego un siguiente taller, que es el taller lúdico de formación para la caminata botánica ecológica, donde ahí, digamos, precisamente con las niñas y los niños vemos todo el tema de los aspectos logísticos, la normativa, cómo van a hacer la observación, el registro, ¿verdad?, de la biodiversidad de los ecosistemas, etcétera. Y la fase 3, que es la verificación de aspectos logísticos y la realización de la caminata en sí. Aquí ya esto ya, lo de la fase 1, ya entré un poco, digamos, a explicarlo de forma más detallada. Voy a pasar rápidamente de acá. Esta fase la podemos definir como una fase preparatoria, o sea, de lo que es la organización, la institucionalidad y todo, digamos, o sea, la parte del cuerpo docente y fortalecimiento de capacidades, la podríamos definir así. Y también luego ya entramos a la fase 2 que les contaba anteriormente, que aquí está la parte de formación en educación y cultura ambiental, los talleres lúdicos. Aquí tenemos, digamos, precisamente, comenzamos con este primer taller que hablamos precisamente de lo que es la Reserva de Biosfera Transfronteriza Trifinio Fraternidad, el Corredor Biológico Trinacional Montecristo. Aquí podemos ver en el taller de Educación, Cultura Ambiental y Desarrollo de Identidad a las niñas y los niños, y aquí podemos verlo en la parte, digamos, derecha, que están trabajando precisamente lo que son sus cuadernos de botánica y de biodiversidad, y lo hacen con sus maestras, con sus maestros precisamente, ¿verdad? Y lo hacen también con las mamás y los papás. ¿Qué designa, verdad? La Escuela de Madres y Padres, que son los que y las que van a acompañar precisamente en la caminata con las niñas y los niños, precisamente. Esta es una actividad que encanta muchísimo a las niñas y los niños precisamente porque lo hacemos, estas intervenciones a través, tiene mucho arte, tiene mucho, digamos, enfoque lúdico y echamos mano, digamos, o sea, de todas las ramas del arte, de hecho, acá, ¿no? Y aquí pueden ver precisamente la parte de cómo vamos desarrollando, o sea, todo un tema relacionado con la sensibilización hacia el cuidado, ¿verdad? Y fortalecer el vínculo con la madre tierra y su biodiversidad y sus ecosistemas como eje central, digamos, de la intervención. Acá tenemos a diferentes centros escolares, precisamente con las niñas y los niños mostrando sus cuadernos terminados, que son los que van a utilizar precisamente en las caminatas botánicas el día que se realiza la caminata botánica y de biodiversidad. Y luego entramos precisamente a la fase 3, que es la realización de lo que es la caminata botánica ecológica en sí. Y luego determinamos una hora muy temprano. Normalmente en las caminatas botánicas salimos a las 6:30 de la mañana, máximo 7 de la mañana. Prácticamente es de todo el día la caminata, ¿no? Y luego tenemos una verificación, o sea, dentro del protocolo, es decir, hay todo un protocolo de intervención que tiene la herramienta, en donde verificamos que todas las niñas y los niños, o sea, y los jóvenes tengan su cuaderno de botánica y biodiversidad que han diseñado. También, ¿verdad? Que lleven los recipientes, o sea, de hechos respectivos, porque por regla y como parte de la educación y la cultura ambiental no generamos ningún tipo de desecho, es totalmente sostenible y sustentable, digamos. Todo, digamos, la intervención es sostenible e integralmente, digamos, o sea, sustentable. También cargamos las guías botánicas y de biodiversidad. También utilizamos ciertas aplicaciones como iNaturalist, que enseñamos, digamos, en el proceso a utilizarlas a las niñas y los niños. Olvidé decir eso, que también enseñamos a utilizar esta herramienta, pero primero a trabajar, digamos, o sea, con las guías precisamente para posteriormente utilizar lo que es la aplicación en sus teléfonos celulares, porque generalmente estas niñas y estos niños son del área rural, no hay ni señal, no tienen prácticamente señal para ir utilizando sus teléfonos y lo tenemos que hacer, como dicen, caminando, a pie, utilizando, digamos, o sea, las guías. Luego entregamos, o sea, lo que son sus alimentos saludables y sustentables, y cada una de las niñas y los niños, sus papás, sus mamás, llevan lo que son sus recipientes. Hacemos todo un tema de logística de organización del grupo, donde también nosotras y nosotros por parte del equipo de Gaia vamos acompañando, digamos, a cada uno de los equipos. Los dividimos en equipos, o sea, precisamente trabajo bajo el enfoque también, el enfoque de género, que haya siempre la paridad de niñas y niños participando dentro del grupo de la totalidad. Y luego también salimos, digamos, a la caminata y vamos precisamente a nivel de los grupos, y siempre hay uno coordinador general o coordinadora general precisamente de la caminata, que va verificando, o sea, que todos los aspectos se vayan desarrollando y que cada uno de las y los coordinadores de Gaia, pero también va una coordinadora o coordinador adjunto, que es una de las niñas y los niños de los grupos. Es decir, ahí vamos desarrollando todas sus capacidades también de liderazgo. Y de liderar precisamente su grupo, es decir, vamos tutelando. En Gaia, vamos, los que coordinamos cada uno de los grupos, vamos tutelando a las y los coordinadores que lideran, o sea, los grupos que generalmente son niñas y niños que van liderando, que no son sus maestros van apoyando toda la parte de los procesos, maestras y maestros y sus mamás y sus papás, pero son las niñas que lideran, o sea, en sí los equipos. Y luego vamos utilizando los cuadernos, vamos haciendo las paradas estratégicas. Previamente establecemos, digamos, una ruta de recorrido, que son las rutas por los senderos, donde son áreas naturales protegidas, ¿verdad? Pero hay zonas, o sea, en donde no son áreas naturales protegidas declaradas, pero que sí son territorios con regímenes de alguna manera de protección. Y luego hacemos, a partir, el mayor tiempo se va pues en recoger la parte de las muestras, tomar fotografías, hay que tomarlas, recogerla, pegarla en el cuaderno, luego identificar, digamos, el nombre común, el nombre científico, la familia, los usos, ¿verdad? De hecho, el beneficio ecológico de las diferentes especies que se van identificando. Y posteriormente hacemos una puesta en común, todos los equipos con sus maestras, maestros, las y los coordinadores, con las y los coordinadores adjuntos, pues presentan la parte de los resultados al final, ¿verdad? Y acá tenemos lo que es, lo que yo les he venido contando un poco en fotografías, ¿verdad? De forma gráfica lo pueden ver, que vamos, esta es, digamos, ya en la acción, las caminatas botánicas ecológicas en todo el territorio circundante de las niñas y los niños. De lo que se trata es, y como objetivo, como al principio se vio, es lograr establecer la línea base de biodiversidad y componentes abióticos con la participación inclusiva y participativa, digamos, o sea, de las niñas y los niños. Y me avisan, o sea, si voy con el tiempo o si ya me pasé del tiempo, me avisan. Creo que todavía estoy dentro del tiempo, ya termino. Y acá tenemos, ustedes pueden ver acá la muestra de cómo las niñas y los niños van recogiendo, digamos, precisamente las muestras. Aquí, por ejemplo, están registrando una especie de tortuga. Aquí están registrando precisamente una especie de helecho. Y vamos también verificando y registrando los factores abióticos precisamente en el recorrido y vamos haciendo dinámicas para manteneros en alto la energía del grupo, aunque ya de por sí la caminata es extraordinaria y mantiene en alto y al tope, o sea, de hecho siempre la energía de las niñas y los niños. Acá ustedes pueden verificar cómo las niñas y los niños van consultando precisamente las guías, vamos facilitándoles, no enseñándoles, facilitándoles que fluya su conocimiento, o sea, de hecho ancestral, porque de hecho las niñas y los niños y sus papás tienen mucho conocimiento. De hecho, porque viven en los territorios, ¿verdad? Y aquí, por ejemplo, están anotando en las paradas precisamente, haciendo los registros, consultando guías, ¿verdad? De forma muy dinámica, aprenden a trabajar, o sea, de hecho, en equipo, muy fuertemente también, ¿verdad? Acá tenemos, cuando vamos a áreas naturales protegidas, parte del equipo, digamos, o sea, facilitador, junto con el equipo Gaia, son nuestros compañeras y compañeros guardarrecursos o guardabosques también. Acá también, dentro del proceso y como es transversal, enseñamos, o sea, toda la parte de los valores de vínculo con la madre tierra. Y hacemos lo que son unas dinámicas, por ejemplo, Abrazos Verdes por el Planeta, que es una campaña permanente que tenemos. Y también enseñamos en ese proceso, facilitamos, o sea, todo un proceso, digamos, de vinculación de las niñas y los niños, o sea, con la naturaleza, de fortalecer el vínculo, de hecho, que ya tienen para que no lo pierdan en su totalidad cuando crezcan. Y hoy por hoy, digamos, esta es una metodología aprobada que la sistematización, o sea, creo que ya no hay tiempo para poner el video. Ustedes, vamos a ver si me dijeron 10 minutos ahorita, pero creo que me lo dijeron al 41. Entonces creo que mi tiempo ya terminó, solo termino de pasar la siguiente diapositiva. Acá voy a pasar los videitos, eso acá. Y bueno, aquí pueden ver, digamos, como parte del proceso, los registros precisamente que las niñas y los niños hacen de la biodiversidad, o sea, de ecosistemas, de componentes bióticos, de hecho y abióticos. Y esos cuadernos prácticamente son obras de arte que se hace una feria al final y luego está dentro de la currícula y son evaluados, porque eso forma parte, digamos, o sea, del acuerdo global con el Ministerio de Educación y con las escuelas, que el cuaderno botánico y de biodiversidad no solamente es para las caminatas botánicas y de biodiversidad, sino que las niñas y los niños siguen posteriormente en sus casas, en sus salidas que hacen ya de forma particular con sus papás, siguen haciendo los registros y este cuaderno, pues al final hay una feria, digamos, o sea, de exposición en donde se presentan toda la parte, digamos, de estos resultados. Bueno, mi intervención es hasta ahí y quedo a su disposición por si hay alguna pregunta al respecto. Muchas gracias.
Thank you, Berta, for this wonderful talk
Thank you.
and for joining us here today. And now it's my pleasure to introduce Katrin Hayashi, who is CEO of Triumph Innovations, which is a commercialization arm of Triumph. Unfortunately, Katrin was not able to join us here today in person. However, we have her talk pre-recorded, and she will tell us about environment and sustainability at Triumph. Our apologies, we have slight technical troubles to play the video. If you can just bear with us for a few minutes.
So what is Triumph? We are Canada's Particle Accelerator Center. We're a world-class hub of research, education, and innovation. We're home to about 600 staff and students, and we've been around for over 50 years. We are a national asset driving research locally, nationally, and internationally, connecting Canadian researchers to the world. So we have a really unique facility at Triumph. We're on 13 acres, and we're the only facility of our kind in Canada and really unique in the world. In total, we operate 6 cyclotrons and 2 linear accelerators on site. We have over 1 kilometer beamlines delivering particles to targets and detector systems across our site. The heart of Triumph has been and probably always will be our 520 million electron volt cyclotron. This is a photo taken when it was still under construction. As you can see, it's a remarkable feat. It's over 18 meters in diameter and has been generating incredible science for over 50 years and really is still the key to much of the science that we are doing now and will be doing in the future. At Triumph, we have been thinking a lot about sustainability and environment the past few years. And in fact, we recently developed a new 20-year vision. So we developed a new 20-year vision document in 2022 called Discovery and Innovation for a Better World. And it really lays out some of the things that we think are really important for Triumph and the world between 2022 and 2042. As you can see, we want to be a global leader in discovery science, but we also want to drive use-inspired research, particularly in the green technology area, and we want to leverage our infrastructure and expertise to make an impact that's going to change the world. As you can see, we also want to be an innovation hub, translating discovery science into sustainability solutions. So I think it's become an increasingly important piece of what we do, and we're really interested in trying to play a role in addressing the global challenges that we're all facing. We do have a track record of research leading to impact. And so, one of the things that we have done in the past was create a consortium to develop a new production process for technetium-99m, a medical imaging isotope that is very commonly used, the most commonly used imaging isotope in the world. There was a critical medical isotope shortage that resulted from the closing of the Chalk River reactor in Eastern Canada. So Triumph led a consortium to develop a new technology that uses tabletop cyclotrons located in the basements of hospitals. So that means we don't have to rely on a few large nuclear reactors that must then ship imaging isotopes to clinics all around the world and deal with the resulting carbon footprint, that hospitals can produce the amount of isotopes that they need locally. So this technology has been licensed to a successful startup company called Artemis and is now commercially available. We're also looking at impacts in other sectors. So for cleaner and greener mining technology, we have an incredible technology that is based on muon detectors and artificial intelligence. So the project is called Earth X-ray for Low Impact Mining, and it's a project that will enable mining companies to identify density and magnetic anomalies with greater resolution and certainty up to 1 kilometer beneath the Earth's surface. So really what it gives you is an X-ray-like image of the Earth. And so that means you have to do less digging. The detector has been now miniaturized to the point where it can fit down a borehole. It's a really exciting project. And in fact, IDEON is the lead on a $13.5 million Canadian digital supercluster project that includes Simon Fraser University, Diaz Geophysical, Microsoft, Firewood, Zinc, and MyTax. So we're really excited about the future of mining and the impact that we can have on that front, all related to muon detectors. So what other climate changes can we address? So we know that green power is needed to fight climate change, and nuclear power is a really important piece of that solution, but it does have its own challenges. And nuclear power challenges include high-level, long-lived nuclear waste, the risk of nuclear incidents, and it is in fact costly to manage and store the waste generated from nuclear power reactors. In addition, not all nuclear power reactors are created equal. So the waste stream that results from using Canadian CANDU reactors requires a different specialized solution because the waste is different from the reactors that are used in other parts of the world. So this is just a diagram of a typical nuclear reactor. There is a nuclear reaction. Steam is generated, and that steam is used to generate electricity. And in an accelerator-driven system, the nuclear reactor would still do its work. However, the leftover nuclear waste would then be irradiated by a cyclotron. And once that cyclotron irradiates the waste, another generation of power is created. More heat, more steam, and therefore more electricity is created. And then the other piece of it is that, in fact, we're using nuclear waste to produce power, and we're also making that waste far less radioactive. So what we are looking at then is a subcritical process that has zero risk of nuclear reactor meltdown that would be caused by a runaway chain reaction in a typical nuclear reactor. It would run on used nuclear fuel, very, very highly economical on that front. And then it's burning these long-lived radioisotopes, resulting in a significant reduction of high-level radioactive waste inventory. So let me just give you an idea of the scale of this. So right now, the nuclear reactor waste, when there is no reprocessing of the waste, it takes approximately 300,000 years for that waste to decay down to the level of natural uranium in terms of radioactivity. So there are processing systems that are deployed in France, the UK, and the USA, where the fuel is reprocessed, and that means that the decay cycle shortens to around 10,000 years. With ADS, accelerator-driven systems, using a cyclotron, the cyclotron would transmute the fuel, and it would take the decay cycle down to around 300 years, which is a much more imaginable time for us to be dealing with the waste. So I think we're really excited to try to do some research in this area, and we'll be working on a white paper in the coming months to elaborate a little bit about how we might think it work and what the challenges might be for such a solution to be implemented. We're also working with other groups, collaborators and companies on their clean energy projects. There is a company called General Fusion, which is a Canadian company actually based in Vancouver, British Columbia, actually one of our suburbs called Burnaby. And they have a technology that they hope will generate fusion power in the future for the Earth. One of the things that they need to do is to provide a proof of concept using a neutron detector. And so we are working with them to deploy our expertise in photon sensors into developing a specialized custom designed neutron spectrometer for general fusion. The project is going really well, and we're really happy to be working in a collaborative way to try and advance this technology innovation. We're also working with other people in this field, groups including Canadian Nuclear Laboratories, where we're working to help them characterize materials used in their small modular reactor projects. There's also a Canadian company called Dual Fluid, which is working on a different small modular reactor project. And again, working with them to leverage our expertise and infrastructure to help them characterize some of the materials that they would like to deploy in their technology. In terms of other clean and green projects, this is a really exciting one. How do we take the concepts that we discover as part of our discovery science activities and apply them to real world problems? So this is a photo of a technology that is used in a neutrino experiment. So this is a photo from Super K. And one of the projects that is now in process is a project called Hyper K. So Hyper Kamiokande is going to be a neutrino observatory in Japan. And this is a science project of global proportions, literally. The Hyper Kamiokande will feature a ultra pure water tank that holds 250 million liters of water in a tank that is approximately 70 meters high and 70 meters in diameter. And it's lined with all of these neutrino detectors. This project would be 8 times larger than the current Super Cave project in Japan and be located 650 meters underground to reduce sort of the interference by surface level radiation. There are 20 countries participating in this quest for neutrino detection, and Canada is in a lead role here. But we had one of our researchers think, oh, well, how could we deploy this technology in a real world setting? So the success of that project depends on the water in the tank maintaining its crystal clear purity. And so they've developed these detectors to try to monitor the water in the tank to ensure that it stays as clean and clear as possible. So can we take that same technology and use it as a real-time water monitoring technology for drinking water? That's sort of the question that we're asking. And one of our researchers, Dr. Akira Konaka at Triumph, is leading a project to try and figure this out. He's collaborating with researchers from Saskatchewan, from Manitoba, and one of the Canadian First Nations to see whether we can actually develop, build, and test a prototype to see whether this clean water monitoring technology can be used to help monitor drinking water for some of our remote communities. We can also use the same underlying technology, which relies on single photon analyzers for clean air monitoring. So this is, again, using that same underlying technology, but trying to see whether we can deploy it to test whether our air is clean. So we have another set of researchers that are using the same technology to see whether they can develop forest fire detectors, clean air monitoring detectors. So we'll see how that project goes. We're also enabling better batteries and new quantum materials at Triumph. And again, part of developing these new technologies is really understanding how they work and how the materials in the components work to make better or worse batteries and quantum materials. So this material characterization piece is really important, and it's something that Triumph has some unique capabilities in. So we have a combination of spin polarized local probes that can help researchers characterize the materials that they are developing. So how can this be useful? We can develop with our researchers better lithium-ion batteries that may enable future generations of electric vehicles. We're also enabling better grid storage batteries for clean energy transition. So maybe our houses would be able to be powered by storage batteries instead of oil or hydro. Quantum materials can also be used in new superconductors, thin films, nanomaterials, magnetic materials, things that are used in advanced computing. All of these advanced applications require a deep understanding of how the components and materials actually work. So at Triumph, we have some really special probes, MUSR and beta NMR probes that our expert researchers can work with materials researchers to help them understand and characterize and determine which battery materials are better than other battery materials. So thanks very much. That's just a little glimpse into some of the projects that we're working on. If you have ideas that you'd like to share or collaboration opportunities, please don't hesitate to contact me. I'd love to hear from you, and have a wonderful World Environmental Day. Thank you. Bye.
Now, following Catherine's talk, we are happy to invite you to watch a video, Science Meets Sustainability, which features 3 Triumph scientists talking about how their research connects to sustainability in their native languages.
María Karner y soy una investigadora postdoctoral en Triumph. Es un gusto hablar con ustedes en honor del Día Internacional del Medio Ambiente. Para mí, sostenibilidad significa usar de una manera responsable los recursos naturales. Y eso significa disminuir nuestro consumo. Pero tenemos que tomar en cuenta que los países ricos y las compañías usan muchos más de esos recursos que los demás. Y cuando implementamos leyes y pólizas, tenemos que considerar eso. No responderé directamente, en vez daré unos ejemplos. Yo creo que las ciencias pueden mejorar la manera que extraemos recursos, que esa manera sea más verde y más eficiente. También creo que podemos diseñar nuevos materiales, por ejemplo, que tengan las propiedades deseables del plástico, pero sin tener el impacto ecológico. Yo trabajo con un tipo de resonancia magnética nuclear que llamamos en inglés Beta Detected NMR. En esta variación usamos isótopos radioactivos con vida media corta que emiten partículas betas, o sea, electrones o positrones de alta energía. Con nuestra técnica estudiamos una gran variedad de materiales, incluyendo materiales para baterías, como ánodos, cátodos o electrolitos. Y realmente lo que estamos buscando son materiales más eficientes y para mejorar el diseño de baterías.
Je suis un scientifique à Triomphe. Ça fait maintenant 20 ans que je suis ici, après avoir fait ma thèse en France, que j'ai terminée en 2000. Quand j'ai commencé ma carrière, donc il y a presque 25 ans, ce qui m'intéressait avec la physique, c'était d'avoir des solutions, disons, au développement durable, où on savait bien que la population allait devenir difficile à gérer sur la Terre. Je pensais que on pouvait apporter des solutions à long terme en faisant de la physique fondamentale, des choses qui peut-être nous permettraient de voyager hors du système solaire. Et puis avec le temps qui passe, on voit bien qu'on n'a pas ces solutions à long terme, et de plus en plus on a des choix à faire à court terme. Pour moi, la révélation, ça a été un jour où je prenais l'avion pour Toronto, où il y avait des feux de forêt de l'État de Washington qui étaient très importants, qui m'ont vraiment rappelé que maintenant c'est le moment de faire quelque chose au niveau du développement durable et de faire que notre planète peut continuer à évoluer et en trouvant des solutions à court terme plutôt que des solutions à long terme, comme celle à laquelle je pensais quand j'ai commencé ma thèse. La solution, c'est clair que la solution est en partie vient de la science fondamentale. Il y a beaucoup de choses à faire pour gérer le changement climatique. Il y a des choses qu'on pourrait faire avec l'ingénierie. Les changements de comportement, en fait, sont difficiles à adopter. Donc finalement, c'est clair que la solution, c'est une solution scientifique, une solution qui passe par des solutions d'ingénierie, mais aussi par vraiment des technologies nouvelles. On sait très bien qu'il va falloir développer des choses qui n'existent pas à l'heure actuelle pour vraiment être capable de gérer le changement climatique. Je travaille principalement sur la physique des astroparticules. Il y a beaucoup d'expériments au Canada qui sont à SNORLAB, qui est à Sudbury au fond d'une mine. Et depuis ici à Vancouver, je travaille sur les expériences qui étudient les neutrinos, qui étudient la matière noire à partir de technologies principalement de photons, de détection de photons. Donc ils sont des tout petits flashs de lumière qui sont produits soit par les particules de dark matter, soit par les neutrinos qui font différents processus. Donc je travaille sur deux choses différentes. La première, c'est celle qui m'a motivé au début, c'était sur l'étude des feux de forêt, en particulier, est-ce qu'on peut détecter les feux de forêt très rapidement pour pouvoir les éteindre dès que possible sans qu'ils deviennent des grands feux. Vous savez peut-être qu'il y a beaucoup de systèmes avec des caméras, soit sur des satellites, soit sur des endroits fixes sur la Terre. Mais ces systèmes, ils ont besoin de feux assez importants pour les détecter. Alors que si vous avez fait du camping, vous savez qu'on peut sentir la fumée très rapidement. Elle se développe beaucoup. Et donc l'idée que nous développons, c'est une idée qui est basée sur la détection de la fumée à partir de petits détecteurs qui sont basés sur la détection de photons. Et donc qui est notre expertise directe. Donc on fait ce développement de détecteurs de photons beaucoup plus sensibles que notre nez, qui peuvent mesurer les feux très rapidement et les éteindre, en particulier à côté de là où les gens vivent, à côté des villes, comme ici en Colombie-Britannique. On commence à travailler avec des compagnies qui développent des sensors, des solutions embarquées qui peuvent être déployées dans les forêts, et nous on donnera notre système de détection de la fumée. Donc ça, c'est la première chose. La deuxième chose, on travaille aussi avec des compagnies qui développent la fusion, ou au moins une compagnie qui développe une solution pour la fusion, et dans ce cas-là, on développe avec eux une solution pour mesurer les neutrons qui sont produits par la fusion. Et ces neutrons, on nous demande de mesurer leur énergie, même s'il n'y en a pas beaucoup qui sont produits, mais cette mesure de l'énergie permettra d'étudier les performances de cette facilité qui produit de la fusion et qui à terme produira de l'énergie proprement. En tout cas, on espère. Donc on fait ces deux choses, mitigation et trouver une solution pour produire de l'énergie sans créer de gaz à effet de serre.
我是李小月，现在是 Triumph 研究员，我的主要研究方向是重微子震荡。物理学的基础研究往往很大程度上依赖于最前沿的科学和技术，这些科学和技术是可以促进可持续发展的研究领域的进展。例如我们合作组正在研究怎样用高厘米光子探测器进行对饮用水质量的监控。这项技术的来源是中微子探测器中对高纯水质量的测量和监控。我认为可持续发展和科技的创新是分不开的。真正的可持续发展要求我们从根本上改变我们衣食住行的方式和来源，来降低人均碳排放，减少我们对高污染产业的依赖。实现这些都需要科技的创新。科研机构包括 Triumph 在内，很注重培养年轻一代的科学家和工程师。这些年轻人将来会成为可持续性发展领域的中坚力量。
À l'occasion de l'année internationale des sciences fondamentales pour le développement durable, le Conseil de recherche en sciences naturelles et en génie du Canada, CRSNG, et le Fonds de recherche du Québec, Nature et Technologie, FRQNT, ont fait équipe pour organiser une édition spéciale du concours de vidéo Science Action.
Le concours mettait au défi les membres de la communauté de recherche d'aider les Canadiennes et Canadiens à découvrir comment les sciences et le génie contribuent à leur compréhension du monde et de l'univers dans lequel ils vivent. Ils devaient le faire en présentant les personnes, les travaux de recherche et les innovations qui transforment notre façon de vivre et de travailler.
La recherche en sciences fondamentales est essentielle pour mieux comprendre et relever les grands défis de notre société, tels que le changement climatique. Elle permet de mettre au point des outils utiles à une prise de décision éclairée et de produire les compétences essentielles à la formation d'une main-d'œuvre hautement qualifié qui pourra trouver des solutions pour un avenir meilleur et durable.
Les universités et collèges canadiens jouent un rôle clé dans la recherche des solutions pour atteindre les objectifs de développement durable établis par l'Organisation des Nations Unies. La présente édition spéciale du concours Sciences Action vise les étudiantes et étudiants de cycle supérieur qui travaillent ou qui ont travaillé à des travaux de recherche financés par une subvention de CRSNG ou de FRQNT.
Ces personnes étaient invitées à soumettre une vidéo de minutes présentant les travaux de recherche auxquels elles participent. Nous avons reçu des vidéos des 4 coins du pays.
Toutes les vidéos présentées dans le cadre du concours faisaient ressortir les bienfaits de la recherche dans les domaines de sciences naturelles et de génie, en établissant un lien entre les sciences fondamentales et les objectifs de développement durable.
C'est un honneur pour nous de présenter les 6 vidéos gagnantes de cette édition très spéciale du concours Science Action.
Nous sommes convaincus que vous aimerez ces vidéos tout autant que nous et nous vous encourageons à faire découvrir à votre famille, à vos amis et à vos collègues.
Due to population growth, industrialization and climate change, the world is expected to face water crisis. Desalination and water recycling are potential solutions. Membrane technology is the most energy efficient technique among all water purification technologies. Membrane as the main part of this system separates salts and impurities. Advances in membrane materials are needed to improve the efficiency of water purification systems. At the University of Waterloo, Applied Nanomaterial and Clean Energy Lab, by using nanotechnology, polymer science, and computational chemistry, we developed a hybrid selective layer with a thickness of 20 nanometer, 5,000 times thinner than human hair. This novel tube membrane filters dirty water twice as fast as traditional membranes, resulting in a more efficient purification system. This research significantly contributes to the achievement of the Sustainable and Development Goals for clean water and sanitation and other cross-cutting themes.
L'échographie est une méthode d'imagerie médicale qui utilise des ultrasons, soit des sons inaudibles pour l'humain. Pour produire une image, on émet des ultrasons avec une sonde, puis on mesure la réflexion produite à la rencontre d'un obstacle, comme un visage. Toutefois, la qualité de l'image produite n'est pas toujours optimale, car elle dépend grandement de la sonde utilisée. En effet, plus notre sonde a de transducteurs pour émettre et mesurer les ultrasons, plus on pourra construire une image de qualité au détriment de la vitesse de calcul. Comme solution, le CRASH travaille à développer une sonde échographique munie d'un masque de codage, ce qui permet de déguiser la sonde en une sonde qui a plus de transducteurs. En fait, un masque de codage est une lentille à la surface très irrégulière qui déforme les ultrasons et enrichit le signal mesuré. Cela permet de réduire le nombre de transducteurs pour produire rapidement une belle image. Différentes formes de masques de codage pourraient même servir à élargir le champ de vision de la sonde, un autre effet des masques de codage qui aide la santé des humains et réduit les inégalités médicales conformément aux ODD de l'ONU.
Les forêts canadiennes vont faire face à beaucoup de problèmes. Il va y avoir plus de feux de forêt, plus de sécheresse, mais aussi des épidémies et des espèces invasives. Et tout ça risque de réduire leur fonction importante pour la planète. Il y a peut-être une chance de les aider à s'y préparer. C'est le but des recherches menées par notre équipe à l'Université du Québec à Montréal. Notre mission, c'est de regarder si on peut diversifier les forêts par l'aménagement forestier et voir si cela peut préserver leur fonction dans un futur incertain. Pour ça, on utilise des modèles informatiques de pointe pour prédire comment les forêts vont évoluer. On varie la manière dont on les gère, le climat, et on leur fait subir des catastrophes pour voir comment leur fonction perdure dans ces différents scénarios. On simule au total 4 millions d'hectares de forêts québécoises dans 240 simulations différentes. Un travail de titan réalisé par les superordinateurs canadiens accessibles aux chercheurs. Il y a de l'espoir dans la lutte contre les changements climatiques. Mais on doit préparer les forêts à un monde qui va changer.
You've probably heard of HIV, a virus that leads to a dangerous weakening of the immune system called AIDS. And while there are effective treatments against this infection, there is still no cure because HIV can lay dormant for years, and cells infected with a dormant virus are not eliminated by anti-AIDS medication because they look just like healthy cells. The problem with dormant viruses is that they can wake up if treatment is interrupted and cause irreparable damage to the immune system. HIV becomes dormant through different mechanisms, one of which involves a pause in its production. I'm studying the possibility of awakening dormant HIV by overcoming this pause with the help of the hepatitis delta virus, or HDV. HDV produces a small protein that has shown very promising results in overcoming this pause in production when used on dormant-like HIV in the lab. By awakening dormant HIV with this HDV protein, or a similar compound, we aim to make the healthy-looking infected cells finally be recognized as infected and eliminated by the anti-AIDS drugs.
Ammonia. Today, ammonia is one of the most important chemicals in Canada and the world because of its use in many sectors, but most of all, fertilizers, which are vital to much of the food we eat. Furthermore, ammonia is of interest as an energy storage by itself or as an energy carrier for hydrogen. This is valuable as there's a necessity for better energy storage options in a cleaner future. Ammonia is produced by combining hydrogen and nitrogen. However, the overall process generates a lot of greenhouse gases because the hydrogen is often produced using fossil fuels. To help Canada's efforts to meet the UN Sustainable Development Goal of taking urgent action to combat climate change and its impacts, my research alongside the Greener Production Group at the University of Waterloo will be about greener ammonia production. This research aims to help reduce greenhouse gas emissions which are connected to climate change. I'll be performing a cost-benefit analysis on the greener ammonia production alternatives, such as carbon capture systems and electrolysis. I will be using both engineering and economics techniques. The output of my research would be a suggestion on what Canada's ammonia production and industry should look like in the future.
Part of UN Sustainability Goal 3 aims to promote mental health and well-being. The COVID-19 pandemic and the social isolation it caused have highlighted the important role that social bonds play in our mental health. In our lab, we examine the neural pathways and mechanisms that enable us to form social bonds by studying pair bonding in zebra finches. Zebra finches are songbirds that form lifelong pair bonds which can be expressed as a preference for their mate's song. These preferences are partly mediated by dopamine neurons, which are also known to play a role in pleasure, motivation, and learning. These neurons send specific signals to higher-order sensory processing areas in the brain that are important for memory, recognition, and preference. Our lab's current research focuses on the role that dopamine neurons play in the formation of a female's preference for their mate song and the consequences if these signals are lost. Our findings will shed light on the role that dopamine plays in forming preferences in order to understand the underlying neural mechanisms that define social bonds, ensuring better mental health and promoting well-being for all ages.
All right, our last contribution for today for Part 5 is a talk by Dr. Teresa Ryan, Indigenous Knowledge and Natural Sciences Lecturer, Forest and Conservation Sciences, Faculty of Forestry at the University of British Columbia in Canada. Teresa, the floor is yours.
Hello. Thank you very much. I'm going to speak to you today from the ceded traditional lands of the Confederated Tribes of the Warm Springs. I'm going to give you some information from an Indigenous science view as well as a biologist and the science that we know. Insuwilaksa Xani Gu Gelks Disiksu actually means I am a natural scientist in Simalyak, my Tsimshian language. And this is important because this feeds into these ancient connections that I'm going to be talking about. In the Pacific Northwest, we're known as people of the cedar. It's the tree of life. It provides everything for us and has for millennia. the cedar is very important to our identity and to a way of life. We're also known as people of the salmon in the Pacific Northwest, and these two have a relationship, forests and salmon. And I'm going to give you a little perspective about forests and salmon and how we're studying them also in coordination with First Nations and Indigenous knowledge systems in the Northwest.
Teresa, my apologies for jumping in.
Thank you.
We still see the presenter's mode. If you would like to change to a presentation mode.
Oh, I'm sorry. One moment.
Don't worry. Take your time.
That could be. Did that work?
Nope.
Okay. Let's try. Does that show?
No, it's unfortunately still the same.
Oh my goodness. Okay. Let me see. Start again. So start share. I want to share that one. Now, can you see it?
If you click that one, let's see what happens then. I still see it in the presenter's mode.
I can't get out of presenter's mode. So I want to share, and I want
now we see it in the presentation
thank
mode.
you.
Fantastic.
Oh,
Thank you so
sorry.
much.
My apologies. Okay.
No need.
So we'll continue from here. This relationships between salmon and forest is very, very old, very ancient. And this is what Indigenous people are familiar with in the Pacific Northwest. So this is along the western coast of North America, or the eastern part of the Pacific Ocean. And our Indigenous knowledge is very important to understanding biodiversity. And we know this around the world. There are several Indigenous people around the world, more than 400 million, and it's about 6% of our human population. But they contribute to 80% of our remaining biodiversity on the lands that they steward. And so that's all the lands, their traditional lands that are still remaining. We celebrate biodiversity in our cultures. This is a depiction of everything that's used in a Kwakwaka'wakw culture for food, for ceremony, for celebration. So biodiversity is critically important. And these celebrations that we've had in the past were they were banned in Canada for a very long time. And it was a result of not understanding the colonial intersections that Indigenous people experienced. And these social institutions that supported us and actually carried forward our generational knowledge are still continued their practice today, but they give us more than just our ancient ways of knowing. They're part of showing respect and understanding life obligations and roles. These were taken away in Canada, and Indigenous children were forced into residential schools. We're still coming to grips with that. The last one closed in 1997 in Canada. So it was a very long period of time of trauma that is experienced by Indigenous peoples. The United Nations Declaration on the Rights of Indigenous People is something that can help facilitate a reconciliation and help to better provide a better place for exchanging knowledge. And I'll show you some examples. Now, when we think about Indigenous knowledge, we think of everything as connected, above ground, below ground, and things that are within each of these areas, in the water, the things that fly, the things that crawl, they're all connected. And that is typical of Indigenous cosmologies around the world. In our science knowledge, sometimes we think about a linear perspective. Now, these are just examples to show you how we can think about them as maybe what is it, the square peg round hole, they don't necessarily fit together all the time. But in between there, we've got these areas of cooperation, exchange, where we can share information and our knowledge. And we see things going on in our salmon forest region, and we're seeing this in other forests as well around the world, where the management is perhaps not seeing the depth of impact. We see right now, this is a Google map of an area in the Okanagan's of southern British Columbia, known as Douglas Lake. And we look at 1984, the forests across the landscape are fairly lush. We look at them in 2018 and we see they're completely devastated. And this has to change, because this is where we also see we're losing other values that are associated with these forests, such as bears. And bears rely on healthy forests and salmon that come to them. And this relationship between bears and salmon helps feed our forest as well. And we're studying the way that these nutrients are going into the forest floor and being taken up by trees in the forest. There is evidence that bears are and sea wolves on the coast of British Columbia are instrumental in distributing salmon carcasses throughout the forest, where they will decompose and enter into the soils. The Mother Tree is a project that has started with the work of Professor Suzanne Simard at the University of British Columbia. And it's about understanding above and below ground relationships. These massive trees in the forests of British Columbia are disappearing. And we would like to remain, we would like to hold on to the old growth that's remaining at this time, but it's a challenge. So there was a project that Suzanne started in 2015, funded by an NSERC and Forest Enhancement Society of BC funding, and it looks at the relationship of forests. Now, we're in an Indigenous perspective. Subier, the late Bruce Miller, a Skokomish elder, used to talk about the tree people. And the interesting thing about this was how the story talks about the above ground and below ground connections, and particularly the fungi relationships with roots, because everything that's connected below ground gives you that strong foundation. And that's what we see in our communities of people as well. Now, when we think about the fungi below ground, of course, we know about mushrooms, and that's the flora of the underground mushrooms or underground fungal networks. Mycorrhizae means fungus root, and there are thousands of types of mycorrhizae. We've been studying particularly ectomycorrhizae in Douglas fir forests. This is what it looks like underneath a microscope to look at the hyphae. So when we have done our work, we're looking at how things are exchanged below ground, and we're using controlled experiments to look at how things are transferred from one root of a plant, of a seedling, to another root in this picture. We're doing this out in the field too, in the forest. So we have empirical evidence of these transfers across mycorrhizal networks. We also have an understanding of 2 rhizopogon species that were mapped in Douglas fir forests, and showing that the connections, the network connections between the large dominant trees were higher in number than they were with the smaller trees. So it shows significant connections among the forest. So these interactions in a forest, when you're looking down on it, are occurring all the time. At every moment of the day, these interactions are occurring. There are changes over seasons between species. There are changes between different conditions in the soil with moisture and acidity. There are different changes that we're coming to understand from a science perspective. We also did controlled experiments about understanding how seedlings are interacting with the tree from which that seed fell. And there is a definite interaction of that tree providing more nutrients and more exchanges with its own seedling than other seedlings. There's still an exchange with other seedlings, but it is interesting to see that it is occurring more with the large dominant tree. The reason for this study is because there was changes in British Columbia. There were significant losses of pine, and there's a move to a different forest, which would be the Douglas fir forests. So there's not enough information that's been recent with the Douglas fir forest. So that's why we chose these. And we have essentially three main objectives. We set sites, the Mother Trees project set sites along a climate gradient from southern BC up to Fort St. James area. There are 8 sites within the interior Douglas fir zone. And we're also looking at legacy trees. What's the regeneration capacity? And so we're using seeds as well, seed sources, both as they are used in present silvicultural practices from nursery stock, and also looking at those species that we know have already started migrating as a result of a changed climate. So this is a map to show you that climate gradient. And this project looks at, we're using a space for time parameter here, because this project is going to go into the future as well to get the time. And when you're talking about trees that live hundreds of years, this project is going to have to continue through hundreds of years of time. But our space that we're looking at here gives us a climate gradient that's very useful to helping us understand how forests work. We have at those 8 locations in the interior, 5 treatments at 3 different sites. So the first treatment, of course, is the control. The other 4 treatments you see a depiction of here range from a clear cut and then a 10% retention, which is also known as single tree or perhaps seed tree, and then 30% and 60% retention in the forest. This is what it looks like for each of those treatments. Okay, this is uncut control in these forests. And here we have 60% retention. And then here we have 30%. And here we have the 10%. So it's a much different scenario than the clear cut in all of these. And we're making observations as well to changes in carbon in our forests. And this is important when we're thinking about sustainable development goals and we're thinking about climate change and how to mitigate it. So the general photosynthesis formula that people are familiar with, and of course the reverse is respiration, shows us where carbon is. But we're actually sampling the soils and looking at the concentrations in these carbon pools above and below ground. And what we see in the coastal forest is a higher volume of carbon, 600 tons per hectare on the coast, compared to 250 tons in the interior forests. Our coastal site is Malcolm Knapp Forest at the present time, and that's one of our UBC forestry research forests. We're also establishing new sites on the coast. We're in the process of establishing new sites so that we can look at the true coastal variants. And what we see in a difference between Malcolm Knapp here on the left and Vancouver Island on the right, the Vancouver Island being the wet maritime influence, is a significant difference in carbon. 600 tons per hectare at Malcolm Knapp versus 1,300 tons per hectare on Vancouver Island. So we're measuring this above and below ground, as I mentioned. Our control forest gives us a depiction of this graphically when we look at the volume of carbon that's been accumulated since the last glaciation. So when we think about what we're doing now to the forest at a clear-cut stage, we know after measuring our clear-cut sites that we're losing almost 90% of the carbon immediately, just from the clear cut. So then when we think about an 80-year rotation cycle, as that carbon's starting to build up, it gets hammered again. And it gets hammered every time there's a rotation cycle. Much like we've got changes going on in this forest soils that are much like the Dust Bowl of the 1930s down in the US. So this is what it looks like when we have it compared to the previous volume of carbon that was accumulated since the last glaciation. We're losing our sequestration capacity, clearly losing the pools, and we're also losing biodiversity because carbon is supporting that life. Here's a depiction of what the soil profile looks like on the right, where we see these nice, beautiful layers. And what we're finding is that with each iteration of cuts in these forests, that depth gets more shallow. This is why it's starting to look like we're creating a Dust Bowl situation. We're getting more and more shallow soils at each iteration of these clear cuts in the forest. So this is an important depiction of what we need to think about when we're looking at a regenerative forest. We know that we want to have a reconciliation with Indigenous people and First Nations in British Columbia and across Canada, and Indigenous people around the world want greater participation in the stewardship of resources that are important to them. The cedar, the salmon, they have relationships that are important to the function of these forests. We want to conserve our old growth. What we have left is such a small amount and it needs to be preserved, but we also understand and want to have economic opportunities, and it's there with second growth harvesting. We can do the thinning of those forests and reduce the monoculture so that we can bring back diversity into those plantations. We need to have this restoration so that we can increase our biodiversity and increase our carbon sequestration, because it makes a difference for the future. We either have the forest on the left that's dying, or we restore them back to health and something that can be sustainable in our use of these. We're tired of seeing the clear cuts. They're just loading debris on the floor. And with a changed climate, the drought conditions that we had here in BC, such as the highest temperature ever recorded in June 2021 at 49.6 Celsius, and the next day having one of the towns, Lytton, burned to the ground, is clear evidence that we need to take this seriously right now. There's no time to waste. Restoration is so important on the coast because we need to make sure that these forests remain healthy. If we continue to have periods of drought, then we are going to see ignition by lightning sources and other means, perhaps, on these forests as well, and they will burn fast when they have a stem density that is as high as what we see in plantations. So we know that healthier forests are going to give us our biodiversity, and it's going to support the many values that we need here on the coast. We have been also observing the movement offshore of sticks, I call them. These logs are getting smaller and smaller. They're round logs, and they're being shipped offshore. So these are the things that will help change. And as we advance the mother tree in our work, we have all of these things that are interconnected. The mother tree is not a hypothesis. The mother tree is a concept, and there are many facets to this in understanding the complex adaptive systems that are our forests. When we're looking at these relationships above and below ground, and we see the relationships with the fungus roots and mycorrhiza, and we see them very similar to the understanding of an indigenous view, it makes sense that we can exchange this knowledge. We know that the work that we're doing in the interior Douglas fir is just a start, because there are other forests that need to be studied as well. This doesn't necessarily mean the same results are going to be found in forests such as the boreal forest, but the relationships are probably there waiting to be discovered. And it's novel for us to be able to engage this work and Indigenous science at the same time and provide something for our future. Thank you very much.
Thank you, Teresa, so much for this wonderful talk and for joining us here today.
Thank you again.
And now let's circle back to what we have started with, to the periodic table of elements challenge. And I would like to invite Juris Mejia from the International Union of Pure and Applied Chemistry, who will join us live from Ottawa. Juris, please, the floor is yours.
Hi, thank you. I guess I have to thank you all for participating in the periodic table challenge, which we started in 2019 to celebrate the 150th anniversary of the periodic table. and as a way to celebrate science. As you can see in my background, maybe we have had quite a many participants over the years now. We have almost 160 countries, which is quite a lot, I would say. And in some countries you can see, like India, that we can barely see any land over, so that we have so many participants. So it's a nice way for young people to celebrate the diversity of science and be part of this global event. And so for today alone, I can see that we have players from about 15 countries, so quite a international reach already. And we will select we will select 3 players actually from today, who will receive the UPAC periodic table poster signed by one of the 13 Nobel laureates that we have, who have helped creating this challenge for us. And so yes, and I'm happy that IYB SSD has chosen to celebrate this periodic table challenge with us. And as you might have noticed, it's available in all United Nations official languages, so not just English. Thank you.
Thank you so much, Joyce. And with that, we conclude part 5 of today's webinar. And I would like to take this opportunity to once again thank all of the speakers during that webinar for their incredible inspirational contributions and for great discussions that we have. And I'm pretty sure we all enjoyed them equally. The next segment, part 6, will start momentarily, and you can find the link on our 24-hour webinar website. Thank you again from Vancouver in Canada.